forefront of revolutionizing education and technology. It's not merely a company, it's a visionary powerhouse committed to reshaping the way we approach learning and technology. At New Biotics, innovation is not just a buzzword, it's a way of life. With a focus on hands-on experiences, practical learning, and cutting-edge solutions, the company has become a driving force in the release of IT, AI, and robotics. Today, we will unravel the layers of New Biotics, exploring its initiatives, unwavering commitment to education, and the transformative role it plays in shaping the future. Join us on this journey as we delve into the heart of New Biotics, discovering the passion, dedication, and innovation that make it a true trailblazer in the tech industry. Get ready to be inspired by the vision and transformative impact that New Biotics brings to the table. Without further ado, let's dive into the world of GenAI with our esteemed speakers and make the most of this collaborative learning experience. Thank you for being here, and let's make this webinar an interactive and memorable journey for everyone involved. So before going into the session, so let me show the flow of the webinar session. So the webinar will be starting from 4 sessions which is having, and the first session is navigating the landscape of GenAI of 35 minutes. Then we have demystifying generative AI, 40 minutes, strategies and frameworks for AI governance of 40 minutes, revolutionizing healthcare through generative AI, 45 minutes, and thank notes at the end of the session, which will be having a feedback session and an open and Q&A. So each session mostly will be having a poll and a Q&A. Depending on the time, it may be getting varied, and we will be having a feedback session at the end, which will be considered for your certification, which is mandatory also. So thank you. Let us move on to the session 1. So let us start with our today's first session, navigating the generative AI landscape. Dear participants, esteemed guests, and other tech innovators, it's my privilege to introduce our chief guest, Mr. Karthik Ganapathy, Analytics Manager from Ford. With 19 years of expertise in data science, he is the Analytics Manager at Ford Motor Company, leading teams across diverse sectors. Passionate about education, Mr. Ganapathy mentors students and speakers at conclaves. Technically proficient, he excels in Python, SQL, R, machine learning, TensorFlow, Keras, and more. Currently, he spearheads initiatives at Ford using predictive models for warranty claims, NLP for customer feedback, and reducing employee attrition. In previous roles, Mr. Ganapathy significantly contributed to champion analytics, customer segmentation, risk models, and more. His educational journey includes a PGPM in finance, CFA Level 1 certification, and a bachelor's degree in computer science. Join me in extending a warm welcome to our distinguished chief guest, Mr. Ganapathy sir, as we eagerly await valuable insights from his wealth of experience in data science and analytics. Now, let us welcome Karthik sir for sharing his expertise on navigating the landscape of generative AI. Welcome you, sir.
Yeah, thank you, madam. Thanks for that great introduction, and thanks to everyone here for having me on this webinar. So can I share my screen or? Yeah. Okay.
Is it possible for you, sir? Yeah, sir. It's visible.
Yeah, so is it visible? Okay. Yeah, so good evening, everyone. Thank you all for joining this webinar. So I will start with what is the agenda we have for, at least from for my specific part. So I'll start with the history of generative AI. Again, what is the key timelines and what are the key milestones we have crossed. We will look at what are the features of generative AI. So again, generative AI is a vast area, and we would like to, my main goal here in this session would be to demystify some of it, touch upon some of the common terms that are used. Again, this is still evolving, as you know, it's a fast growing field. So some of the terms we use today may not be used 6 months back, or it may be outdated. We'll also look at some of the trends that are emerging in generative AI, look at some of the key terminologies, and specifically I would also like to touch upon applications of Gen AI in specific industries, right? Specifically, I'll be touching upon banking, retail, and manufacturing on what are the use cases. And I will wind it up with a quick demo. So maybe not every one of you may have coded or used generative AI either as an API or other form. You may have used ChatGPT like a console, but I would like just take a couple of examples to run you through how APIs are used to use generative AI. So before I start, I will start with a couple of interesting statistics. So about 75% of professionals expect Gen AI to cause a significant disruption in their industry, right? So this was in an article submitted by McKinsey, and again that shows the kind of disruptions that are waiting to happen due to Gen AI, right? And this was a quote from Mr. Sam Altman. He is the CEO of OpenAI. And as you know, OpenAI is the one who released ChatGPT and is open sourcing many other models. There are about 100 million people who use ChatGPT on a weekly basis, right? So that is a pretty huge number. Again, that's to give you an idea, that's almost like the size of a social network, right? Having regular users weekly 100 million is that's to like 10 crore people, right, using this console every week. So that shows how people across different industries are using this. Okay, so now diving into generative AI, right? So again, this term has been used a lot. So what is it exactly? So it refers to the use of AI for creating content, right? For like image, text, music, audio, or video. So if you notice, all of these are somewhat human-like. So AI, why is it called artificial intelligence? Because it mimics some of the key some of the human traits that are being done, right? So for example, if a person speaks, if a person reads, a person listens, right? So all of these, either text, or if you use an image, if you use an audio, a video, etc. So all of these are human qualities. So that is being mimicked by AI, and specifically generative AI, right? So this term has become extremely popular. It has become like a household name, mainly because of the release of what is called ChatGPT, right? So ever since the release of ChatGPT, I think this term has garnered a lot of attention from people in different industries. And one interesting thing that I noted is earlier it was AI was more related to academic things, like for example, how to classify an image, how to detect whether a mail is spam or not, right? So all these kind of data science, machine learning components we see every day. But this went one level higher, and it started looking at creative fields. For example, how can I write a poem? Right? How can I create an image? How can I create an image that does not even exist, right? An image of a person. So I will touch upon some of these in the next few slides. So that is the power of generative AI. It is the ability to create new content. And the keyword here is generative, right? So by generative, as you know, it generates content. It based on the learning from certain data in the past, it generates content in the future. And here is an example. Draw a picture of a cat. It can create a image on its own, right? You need not have to depend on someone take a photo. It can be created by AI. So what are some of the processes? So these are some foundational blocks I would like to cover. So what is the process in generative AI? The first step, of course, in any data science or machine learning task is collecting data. So in this case, we are collecting a lot of text data. So they call it corpus, text corpus, right? The vast amount of data, several billion records in number, and based on that they do what is called as a pre-training. So pre-training is something like when you have a GPT-3 model, you may have heard it is released by OpenAI. So they pre-train on a vast amount of data. So you can think of it like a head and a body of a person, right? So pre-training is like the body of a person. It is more generic. So it is trained on vast amount of generic data on the internet. But the next step, as you see, fine-tuning is more like the head of a person, right? So you can attach any type of head to a body. So fine tuning is required because you need to customize it to specific occasions. To give an example, right? If let's take an example of a bank. They are in the field of they are trying to build a chatbot for banking customers. So what they will do is they will take a pre-trained model and they will try to customize it to specific banking terminologies, right? Some terms are very specific to banks, and for example, a pharma company can have a very domain specific term. Banks can have a domain specific term. So it's customizing to that. And then we have the prompt, which is what we provide as an input. So generative AI mainly consists of a prompt which you give as an input, and then you get the output content, right? Which is the text or image or video, anything like that. So that in short is like a life cycle of a Gen AI process. Yeah, so these are a couple of examples of generative AI. Many of you would have seen a lot of it. For example, this is the one at the top is a screenshot of chatgpt. So what you see on the left, you get input prompts. You write any prompt, like say, create a particular text or a poem. Write a poem for me in say 500 words, and on the right you get an output, right? A text that is generated through this engine called chatgpt. The other one here is Mid Journey. So this is more like an image generation tool. So you can enter a text saying, look, create an image of a rabbit wearing a hat, right? And the output you get is an image of a rabbit, right? So these are across different types of content. So for the input is a text, the output is an image, right? So this is another specialty of generative models. They can move across different modes. So I would like to give a quick classification of what is generative and what is discriminative AI, right? Just generative versus discriminative, and how did this term really come? Generative, like I said earlier, it generates content, so it looks at the data from the past, learns from it, and it generates new content. So that content can be text, image, video, audio, anything, right? And specifically, this is what helps in Gen AI being more creative, helping in creative areas. So that is more on the generative side. So what is discriminative? Discriminative is when you want, like, typical classification task. We can take an example of a mail. So if you want to classify as a mail as a spam or not a spam, so we all use emails, and we get a lot of emails which are junk. So that's classified as spam or not spam. That's a good example of discriminative, where you say, okay, should I make it as a spam or should I make it as a not spam? So it is more like a classification task. So this is a short history about AI. So again, there's been a lot of progress made in the last decade, 10 years or so, but I will cover it. So somewhere in the mid of 20th century, you had what is called a Turing test. So this was introduced by a person called Alan Turing. So this is to determine if a machine, does it pass a Turing test? So what is a Turing test? If a machine can mimic a human being in intelligence, like I said, if a machine can write a poem, if a machine can write a story, right? So that is an example of intelligence that's shown by the machine. So this Turing test was proposed. You also had something called as the expert system. So expert system is rule-based system. Unlike AI system, which is more, it is derived from the data. So rule-based is you plug in the rules for that system for it to accomplish the required tasks. After that, you had what is called as machine learning algorithms. So as you know, there are a lot of machine learning algorithms, and you would have heard the terms machine learning and deep learning, right? So deep learning is a subset of machine learning, and some examples of machine learning algorithms are random forest, XGBoost, etc. And after that, if you see somewhere in around 2005, the cloud computing platforms like AWS, Amazon Web Service, Microsoft Azure, they all started coming into the market. So this was more like cloud computing platforms that were developed. But what is happening now is you see a lot of AI components which were not there earlier. So these are available as plug and play components in these cloud computing platforms. So like AWS, you have Google Cloud Platform, you have Azure. So all these companies have their cloud platforms which we can use to customize and build our own applications. And somewhere around in the last 3 years or so, we had OpenAI, so which is behind ChatGPT and releasing the GPT family of models. So it released GPT-3, and also somewhere around end of 22, you had ChatGPT, which created, it was a major breakthrough, and people all over the world, there was an explosion in people using AI tools. And finally, the word Gen AI, it becomes very popular. So just for the record, Gen AI existed even before ChatGPT. It was a term, but it became really popular with people across industries beginning to use that term. So what are some of the common tasks that can be done in Gen AI, right? So one is text summarization. For example, you can feed in, let's say you want to summarize a lesson, right, that you are teaching to your children. So you want to compress that into say 10 lines or so. It may run into 5 or 10 pages. So you can compress it into say 5 or 10 sentences, right? So that is a gist that you get. Rewriting. So rewriting is like taking a content that is available and rewriting in a different form. For example, you can make the writing in a more legal terms. So legal terms are a little difficult to understand, and you can convert it into a more easy to understand form, like common people can understand. So similarly, information extractions. How can you use unstructured data like PDFs or image extract data from it, like say the name, address, and other details from it. And question answering. Question answering, as you know, you may have a database of say documents, images, videos, etc. And how can you question it? For example, you can say, give me a list of passbooks that are available, right? Or what is the name of the customer who has account number so and so. So this is an example of something used in the banking industry. Classification, as I said earlier, do you want to classify an image? Do you want to classify a text? So if you want to say, does this image contain a bird? Yes or no, right? So that is an example of classification. The next one is translation, changing it from one language to another. You feed in English, you get the output in Spanish or Italian or Tamil or any other languages, right? So that's translation, which is also done. And finally, what is called as reasoning. So reasoning is when you ask a question, when you pose a certain question to the AI model, so you will ask it to explain it or reason. So whenever we discuss with a human, we will say, what is the reason, right? So you want to give a step-by-step way of how something is derived. So that is reasoning here. So these are some of the common tasks that's done using GenAI. Again, it's not restricted to this, but I only tried to cover the most important ones. So transformers. So again, I took this up. Please don't be surprised looking at this. It's a very involved topic, transformers. So I wanted to introduce here just to say that this is like a backbone of most of generative AI models, right, or large language models. So what you can take away from the slide is transformer is it was introduced in a research paper in 2017, and it had a huge effect on the large language model. So how is it? It introduced something called as concepts like self-attention. It introduced multi-head attention, masked multi-head attention. So all of these were introduced. And so in simple words, what it means is it speeded up the process. So whenever a human speaks a certain sentence, you always have a context. So if you speak 5 sentences, the first sentence and the fourth sentence may be related. So that is called context, and that was derived very well by transformer. So this helped in a great way, and it was used in famous models like GPT, BERT, and other models, right? So that's why I wanted to show this to you. Again, if you are interested, you can read this paper on transformers. This available on the internet. It's like a building block of large language, most of the large language models. This is about evolution of models. Again, I wanted to touch upon this to show how fast things have evolved, right? So especially if you see in the last 10 years or so, somewhere from 2017 when transformers were introduced, you can see there's been a lot of progress, and now we are at a stage where you can interact with a system like chatgpt, where everyday humans can interact, laypersons can interact and get whatever they want, right? So we started with RNN. So RNN is called a recurrent neural network, and this was something that they started with for language modeling or NLP tasks, and it was followed by LSTM. LSTM is long short-term memory, which improved upon the RNN or recurrent neural networks. But all of these had certain limitations, which was overcome by transformers. For example, context understanding, that was something that was provided by transformers in 2017, like I said. And following that, you had a lot of family of models like BERT. BERT was released by Google, GPT was released by OpenAI, and so on, right? So if you see most of these large language models, 2019 you had GPT-2, then you had Roberta, which is a variant of BERT, and you had Palm. Palm is released by Google, Llama was released by Facebook, right? So if you see some top 4 or 5 companies control most of these releases that are happening, right? These new open sourced models. So that's another interesting thing to note here. Yeah, so another term I want to introduce here is multimodal. So what does multimodal refer to? So it is refers to systems can understand across different forms of data. So I said there are forms of data like text, image, audio, video, etc. So how can a system understand different forms of data? So we have seen ChatGPT, which says text, it takes text as input and it outputs text, right? So input and output are both text. But can we enter a text as input and get an image as output, or can we enter text and get a video? So what you see here is an example of a text input and an image output, right? So a dog looking in the mirror, seeing a cat, right? So that is the input that you give as prompt, but when you see the output is an image. So this is a classic example of a multimodal. So it spans text, image, audio, video, etc. So again, the reason I am introducing all of these are some common terms you will hear, and knowing this will definitely help you go through this journey. So what are some of the key trends in generative AI? So that's a lot of personalization that happens. So whenever you visit a specific website, you visit a specific shop, nowadays a lot of user data is collected, starting from mobile numbers to address to various other data, right? Your shopping patterns. So Gen AI helps in personalizing. Already a lot of that is being done by companies like Amazon, Netflix, Flipkart, etc. But this is only going to get more momentum as we go forward. Another trend is deepfake technology. You may have heard of this term. So what is deepfake? So it is generating content like image or audio which did not exist, but people manipulate it for some harmful purpose, right? So again, to give an example, recently our Prime Minister Narendra Modi, he had shared that there was a video of him which was not authentic, which was not real, but someone created deepfake technology, deepfake image or video using AI. So that is again something to be careful about, and about which a lot of policies need to be derived. The next one is ethical use of Gen AI. So when you have deep fake, which is causing problems in society, you need something like an ethical policy on how to use AI. So how do you collect data? How do you ensure that there is privacy of customers, right? So that's on the ethics side. Improved accessibility and democratization. So again, ChatGPT is a classic example. As you see, this is like you can access AI through a browser. So all you need to have an account with ChatGPT. Again, the basic version, it does not cost anything. But once you have that account, you can create content, right? You can generate text. Another example is Midjourney, which is about generating images. So all this has been democratized. And like I showed you, there are 100 million users every week using ChatGPT, right? That's one tool. And we are talking about a whole lot of other tools. And then finally, the AI generated content detection. So just like I said, deepfake technology, which creates content that's harmful, which did not exist. You also have something called content detection. So when you see a content, is there a way to detect whether is it fake or is it AI generated or is it real, right? So these are some areas or trends that are mainly evolving in this area. And this is something you can also read upon. There are several other trends, but I found these to be quite interesting. So moving on to application of Gen AI in specific industries, right? So I'll start with banking industry. Again, as you know, banks, they store a lot of financial documents. So it could be your passbooks, it could be the ledger, it could be the customer detail, transactions. All these are stored in documents. So when you say document, it could be like a PDF file, a CSV data file, and so on. But how do you mine all of this in a very quick time frame? We already were using this data, but with Gen AI, a lot of it is being made much more easier to handle. So similarly, virtual assistants, right? Virtual assistant, think of chatbots, how customers reach out to banks and they chat with the customer service agent, right? So this can be automated as well using generative AI. Again, chatbots existed even more than a decade back, but with Gen AI tools, it's become much more easier to develop such virtual assistants. So capital markets research. So here I'm referring to cases where companies file a lot of documents like earnings report, annual report, balance sheets, etc. So if you want to get content or get data, extract data from those documents, that can be done using generative AI. So there's something called document search, using which you can ask questions to the model and it will return you answers. And then personalized marketing. So whenever you receive emails from banks, right, you can see that it's mostly personalized to what you want. For example, you may be a high net worth individual, you may be earning a few million per year, let's say. In that case, they would target you with specific offers that very high net worth individuals only. For example, a credit card, which is not provided to everyone, but only HNI customers. But if you are a student who is, say, 18 years of age and you are having a bank account, so in that case, they would not share the credit card application with you, because your profile and your wealth status will be completely different. So that's what I meant by personalized marketing. So this is one more area in retail, how Gen AI is applied. Product recommendations. So you could think of, like, if you go to Walmart, right? What kind of products? So let's say you go to Amazon. Products are recommended based on your past search history, right? For example, you may have bought a mobile phone, you are offered new accessories on their website. So that is an example of product recommendation. And interactive customer product customization. So again, this is how do you generate images on the fly, right? Earlier, you needed a designer to sit and design each of these, but with Gen AI, all of this can be customized much more easier. Planograms. So planograms is something like a shop floor layout. For example, when you enter a retail store, you would have noticed that everything is arranged in a particular way. So for example, the fruits, vegetables would be in a particular place, the groceries would be a particular place, and books will be a particular place, and so on, right? So that is all planned to ensure that to ensure maximum sales for the particular retail company, right? So that again is being helped by Gen AI tools. So coming to the next field, manufacturing. So I will maybe touch upon a couple of use cases here. For example, training, right? Training is one of the key things that's required in manufacturing. Take, for example, a mobile manufacturer, right? Like Foxconn. That's a company that manufactures mobile phones. So training is one of the key things here for such kind of companies, because they continuously recruit employees and they want to ensure that they are trained properly on their tasks, right? So this can be done by Gen AI. So a lot of training is virtual and Gen AI can help do that. Similarly, robotics and automation. So again, in manufacturing company, think of a car company, right? So you have parts being assembled, you have an assembly line and parts are being assembled on it. So a lot of it is repetitive. So again, that can be automated using generative AI. And finally, a couple of examples in our daily life, right? For example, GitHub Copilot. So I believe some of you here would have been developers, or you may have written code. So GitHub Copilot is a very good example where developers benefit from Gen AI. So there are a lot of use cases, but one specific example is if you want to write a code in Python or you want to write a code in Java, you can use GitHub Copilot, you can describe what you want and it generates code for you. So again, that's an amazing feature that you see in Gen AI. Similarly, blogs and resume. A lot of people, you may be searching for job, writing resumes, or you may be writing blogs, right? So all of this you can, as you see here, right, you enter a particular text or paragraphs and you can ask it to reword it in a more easy to understand form. So broadly, those were the areas that I wanted to cover. Any questions here?
So thank you, sir. That was really a wonderful session, and you gave us the roadmap or the pathway to look into the insights of Gen AI. So with your permission, let me pose a few poll questions. Thank you, sir.
Yeah. Can I stop sharing the video?
Yes, sir. Yes, sir. Yes. So thank you, sir. Really, that was a provoking session. And you have given us, the path or the roadmap which really the participants need. And with your permission, sir, we will go for 2 poll questions and then we will be moving to the Q&A.
Yeah, sure. Thank you, madam.
Thank you, sir. Participants, and let me put the poll link in the chat. Please take up the poll question, and after the poll question, we can go for the Q&A. Meanwhile, you can post your questions in the chat. The chat will be open now. I have shared the first poll question. So participants can take up.
So that's a very commonly used asked question. So again, like I said, Gen AI, the specialty is it has cut across industry. Right? So earlier we were afraid that software developers or the people in working in IT are affected by automation. But with what we saw, some of the examples I gave, you can see that even people in creative field are getting affected. But to answer this question, right? So one common case where people are affected in developers are affected or IT employees are affected is like a GitHub Copilot. So how can you generate code using a Copilot? So they call it pair programming. So what it means is all you need is to give some description about what you want, some specific prompts, and you will get the code as output. But at the same time, while the code is generated, there also needs to be some kind of expertise needed in that particular technology, right? Like a person, it can sometimes the code may not be complete, sometimes the code may be incorrect. So just because you generative AI gave you the answer doesn't mean it's 100% correct. So you need a judgment from the developers as well. So again, that can't be automated, at least as of now it's not foolproof, but I expect in the future it will be much more advanced in that way. But yeah, we need to still be good in the basics and be good at what programming languages we know. The developers, the basics need to be strong because as I said, some of the content may not be relevant, and we need to identify the difference between what is good and what is not good or what is wrong. Yeah.
Yes, sir. Thank you, sir. That was a very detailed answer you have given. And we are going for the second question, sir, which is, can you please clarify more how it can be used in car manufacturing?
Okay, so again, I work in the automobile space, but I won't take any specific company examples, but something which in general that we notice. So you can classify it into domain specific use cases and domain agnostic cases, right? So domain specific cases, for example, in automotive, like I said, robotics or automation on the plant. So that is something that is being done. So designing, car designing, a lot of effort goes into designing, and Gen AI with all its capabilities in image generation, it will help a lot in that front, right? So that's a couple of examples on domain specific case. So I also mentioned domain agnostic. So it's not specific to domain. For example, marketing and sales, right? It's not specific to domain. So you need to sell or market even if you're in retail, even if you're in automotive. So in that area, again, I see a lot of Gen AI use cases like image generation, content generation, recommending new products or new cars based on the customer profile, right? So if you are selling a very high-end car, you can't target it to a student, right? So you need to know the history of that customer, and then you need to accordingly target. Similarly, the case with a middle-aged, high net worth individual, targeting him with a low-end car will not help. So just a few cases that I could think of, but these are ways in which Gen AI is used to market to certain in the automotive industry.
Yes, sir. Thank you for your answer, sir. Shall we take up one final question, which is very different from all general questions? How to be aware or overcome deepfake mechanism, mainly in social engineering?
Sorry, your voice was breaking.
Yes, sir. The question is, how to be aware or overcome deepfake mechanism in social engineering? That is one different question asked by the participant.
Are they referring social media or?
I think like it should be social media. It is not social engineering.
Okay. So yeah, so social media again is area where there is scope for a lot of deep fakes to be used. So again, being careful with our data, that's something that needs to be done. Privacy. So privacy is something that's a lot in progress, even as Gen AI is progressing. Companies are focusing on privacy, right? We saw a lot of examples recently where companies got into trouble with authorities because they did not handle the customer data properly. So these are some policies that we expect companies to focus on a lot going forward, and at the same time, customers also will need to be careful with the kind of data that they share, right, in public. So your profiles and other data, we need to ensure that it's not easily shared in public with proliferation of mobile devices, social media, and several other platforms. As they grow, as Gen AI grows, I think we need to be careful with how our data is shared. Yeah, that's
Yes, sir.
I think how people can be careful to avoid any problems with this.
Yes, sir. With all these ethical considerations, they can take into the particular work or job, sir. So, thank you, sir. Thank you for your wonderful, content, sir. So, thank you, sir. And the participants, we are closing the Q&A here because the other speaker is waiting, and we are moving towards our second session. Now it's time for our another interesting session on demystifying generative AI. Dear participants, it is an absolute honor to introduce our distinguished chief guest for today's webinar, Dr. Sanmitra Sarkar, GM AI and Analytics at IBM. With over 18 years of expertise, Dr. Sarkar is a thought leader and innovator in artificial intelligence and generative AI. Currently leading generative AI projects at IBM, his journey spans over 11 years, where he is emerged as a pioneer in managing multiple projects and RFPs. Dr. Sanmitra's expertise extends into cutting edge concepts in generative AI, including retrieval augmented generation, prompt engineering, and extensive work on large language models. Beyond IBM, he has been played as a key roles at TCS, HSBC, and Nelson Manufacturing, and also like managing multi-million dollar projects across diverse industries. Dr. Sanmitra is not just a practitioner but also an innovator with 10 patent filings and accolades like the IBM Orion Award. As an academician, he shares his knowledge as an adjunct faculty at institutions like IIFT, IBS, and BIMS. Today, we have the privilege of delving into the insights and experience of a true visionary and leader in the field of artificial intelligence. Please join me in extending a warm welcome to Dr. Sanmitra Sarkar as we embark on a journey of knowledge and innovation. Without further ado, let's give a virtual round of applause to our esteemed chief guest. Now, let's welcome Dr. Sanmitra Sarkar to share his provoking thoughts on demystifying generative AI. Thank you for being with us, Dr. Sanmitra, sir. Welcome you, sir.
Hey, thanks. Let me share my screen.
Yes, sir.
Let me know if you can see it. I have a little back throw.
Yes, sir. Yes, sir. It is visible, sir. We can go.
Sure. Yeah, so I think this slide has already been covered by the previous speaker, Karthik sir, but I would like to touch upon a couple of things that this AI terminology was first given by John McCarthy in 1956, which was the first conference of artificial intelligence at Dartmouth College in Europe. But even before that, during the Second World War, the first usage of artificial intelligence came into existence. And thereby, there were various types of other things that came across over the last 50 to 60 years. And definitely, one of the important things, as even mentioned by the previous speaker, is in 2022 when OpenAI came up with this chatgpt. It actually started this journey of generative AI among the common people. So Now, moving on, so artificial intelligence is any technique that enables computers or any machines to mimic human intelligence. This is the superset of machine learning and deep learning. So, machine learning is a subset of artificial intelligence, and deep learning is a subset of machine learning. So, what is machine learning then? If AI is just a technique to mimic human intelligence, machine learning is a subset which uses statistical techniques and other mathematical and machine learning techniques to improve a particular task at hand. And then if we go into the deep learning, this is like it works like our uh, neurons and dendrons. So it is basically tries to identify the root cause of the problem. So it goes absolutely at the deepest level and try to resolve that a problem. And the a problem is not always a single layer; it has multiple layers. So it identifies those multiple layers and goes deep into the branches of those multiple layers and tries to identify the problem at the very root, and it sends back that information back to the original model. So it works like a neuron dendron type of thing. So that is why this neural network, this particular term came from that. And basically deep learning is about all those things, combination of all those things. So this is how you should remember that this is deep learning is a subset of machine learning, and machine learning is a subset of artificial intelligence. I'll talk about the top five AI trends, which has been discussed from the similar timeline of 2022 when this chat GPT came on. So, which is parallelly going with this large language model development, is that computer vision is said to grow, boost in the autonomous vehicle industry, chatbot and virtual assistants are getting smarter, solutions for metaverse, and improve language modeling. So I'll just give example of what is exactly is a computer vision system. So computer vision system is just like your human vision system. Human vision system, there is a picture where we are seeing that there is a bowl of fruits. Now we have a sensory organ called eye, which looks it at the bowl, and it captures the image, and it goes to our brain, and brain interprets that this is a bowl of bananas, tangerines, lemons, and peaches, so a bowl of fruits. So we have to have individual components like we have here in the human vision system. So the sensory device, there should be a sensory device like eye to capture the image. So we use a camera to do that. Now we have to have an interpreting device like a brain to interpret that those different objects which I can see in the image. So we use computer, laptops, and various other interpreting device to do that, so that that particular interpreting device can also say that it's a bowl of bananas, lemons, peaches, and tangerines, like a bowl of fruits. So this computer vision is set to grow, because why? You go anywhere now, you see that if you have to pass a particular secure place, there are biometric mechanism that is in place. Even in offices and institutions, you have to have some biometric system to register the attendance. How they identify? They look at your retina, they take your fingerprints and all those things. So this is going to improve. Now, if a person just crosses a particular system either allows or disallows. So if you go in Europe, there are multiple such areas where you do not have to press anything, or you do not have to swipe your cards. If you just pass by a particular place, there would be acceptance or rejection, whether you'll be allowed to enter that place or you would be rejected to enter the place. How they do that? Again, simple computer vision. There are recordings that how your face looks like. There is a face recognition. and from there they identify, okay, this particular person has the authority to enter into that particular place. So moving forward in a smarter place, smarter world, definitely computer vision is set to grow. If you see the Gartner is a kind of a magazine which so always gives this kind of a direction that what where the industry is going, where the technology is going. In 2021 itself, it said that it would be there would be highest planned investment in computer vision projects, and that is what we are seeing in the last 3 4 years. Now, second is the autonomous vehicle. Autonomous vehicle is another very good example how AI has developed. So from level 0 to level 5 is the ultimate reach of autonomous vehicle. So level 0 is there is no autonomy, but level 5 is there. It would be a completely driverless car. There is no restriction, and a car can go anywhere. So there is no place of even a steering or a brake. That would be done solely by the car itself, car's machine itself, and you just you have a sofa or something like that inside the car to sit and relax and give instruction to the cars to go from one place to the other. So where we are with respect to these different levels, if you have heard the company Tesla of Elon Musk, it has already crossed level 3 and it is testing at the level 4. And if you talk about the Indian context, we have already reached up to the level 2. Even the mid segment, for example, companies like Morris Garage, MS Hector, MS Aster, then sorry, MG Hector, MG Aster. Then you have various other cars. Of course, the high-end cars like Mercedes and BMW have the parking assist facility. You do not have to park your car yourself. You can just ask the give a command to the voice command to the car, and it would be automatically parked. There are cruise controls. If you are running through a highway, if you ask that if you choose this cruise control option, you do not have to press the accelerators or the steering wheels. It would be automatically controlled. So we even in the Indian market, we are at the level 2, and already in the developed market, level 3 has been crossed, and we are almost at the level 4. So we are not very far away of reaching this level 5, where we'll see no drivers are running our cars. So this is another area where there are projections that there are 150, almost close to $150 billion were invested in 2022. So what would happen? Not only the companies like Ford, companies like GM, companies like Mercedes are working in this space, but technology companies, Google is coming up with a car. So see the change that automobile cars were developing the cars, but now even the simple technology companies are also doing the same. So this is another change. We already have talked about the chatbots. So chatbots, how you kind of talk with the different companies, customer service. So previously, we used to have human agents who are actually replying to our queries. But what was the problem? It was only between a certain time, because if one person cannot work 24 hours a day. So the customer service was for say 8 hours, 10 hours, 12 hours. So between 10 a.m. and even if you go to some of the sites, even today, you will see that we can answer your question between 10 a.m. to 6 p.m. because it is being answered by the actual human agent. This slowly and gradually would be fully replaced by the machines and chatbots. This is called conversational AI space, where it would be automatically done. It is already being done using simple traditional AI, but generative AI has also come here. Where generative, for example, IBM had a tool called Watson Assistant. Now it is called Watson X Assistant, because Watson X is our generative AI tool. So it is infused by Watson X or the generative AI capabilities. What is the help. So previously, this chatbots could answer some simple queries. It has a boundary that you could ask only 10-15 types of question, and they are different types. So basically, you have asked a question, and the chatbot could understand that the meaning of this question is something. So they had been trained with this kind of 15-20 different scenarios. Now, with the help of generative AI, it can answer any type of question. It is not always have to work within that boundary, because with the help of LLM and generative AI, they can search for what could be the possible replies. It dig through the different system it has access to, the internal system. Of course, it already has the access to the internet. If that kind of question is asked, it will definitely be able to answer. Even for the internal queries, which you have in some internal database, it can search and answer you back. So that is the beauty of using generative AI in the chatbots. Of course, there are multiple investment in this space as well. Metaverse is another area where, so we were talking about the different patents I have. So one of them is actually couple of them is related to the metaverse and how we will interact with the metaverse, how the advertisement can be measured. What is the effectiveness of advertisement in a meta world? So meta world is basically a world where you are using AR and VR technology. So it's a virtual reality, augmented reality kind of a situation where you immerse into that particular environment with the virtual reality, augmented reality equipments, and there the opportunities of AI are much more, because you can, one is how better experience you can give to the users of the metaverse, as well as how you can do. I gave example of advertisement. I can talk about many other things like what should be the gaming experience, how can improve the gaming experience inside a metaverse. So you can see this customer service, training, events, sales, trading. There can be lot many types of offerings that you can have in the metaverse. So it is also likely to grow. So that is why in 2020, Mark Zuckerberg rebranded Facebook as Meta, because he sees a very good opportunity here for Facebook to do something. And of course, we are talking about large language and foundation models, which is set to grow. So basically, if you are talking about these foundation models or large language models, how they have, what was the journey? So in advanced analytics, we started with the step-by-step and logic and instruction coded by human developers. It is very deterministic. Machine learning, human crafted features with supervised learning to analyze data for a specific task, like predicting which particular customer would default in a credit card payment, pricing, optimization, and so on and so forth. Deep learning was kind of using not only the supervised but unsupervised learning, where AI is fed into outcomes and data to create rules and algorithms like image recognition, autonomous driving, etc. Now, in the foundation models, it is another type of unsupervised AI that ingests massive amount of data. So when we are talking about GPT 4.0, which is now into existence, uses 175 billion parameters. So parameters are not records. Parameters are basically your features, or if you are thinking about an Excel file, your columns are your parameters. So Chat GPT 4.0 has been developed using 175 billion such parameters. So it is trained, or it is pre-trained on so many parameters. That is why it can handle any kind of questions, any type of problems. So where to use traditional AI capabilities? So is traditional AI is going to sunset? The answer is no, because generative AI definitely can do most of this task itself. But if you are looking for higher accuracy, and it is if it is for say quantitative data, definitely traditional AI should be preferred, because you are talking about higher accuracy, as well as you are talking about quantitative data where the accuracy would be much more. But if it is text, if it is a specific use case like summarizing the text content, so doing a conversational search, for example, I ask something and it searches. Content creation, as Karthik sir was talking about, code creation. Now you want to create a code out of a business requirement. Your client has said that. So one of the questions in the previous session was, what is the impact on the software development? One of the major component is how you develop your code. So that is being done by the generative AI. In IBM, we are doing this kind of use cases now, like code generation, code conversion, test case generation. So perhaps in future, in very near future, many testers would not be needed. So yes, there is a chance that there would be loss of jobs. So there is a concern, or there is a question in many areas whether there would be reduction of jobs because of the advent of generative AI. Yes, definitely. But at the same time, there would be new jobs created because of this generative AI. If you can learn the generative AI, there are multiple types of jobs in the generative AI sector itself. For example, prompt engineers. For example, of course, the data scientist. Then people who understand what kind of problems. So architects or generative AI architects who can understand that what kind of business problems can be addressed to Gen AI. So there can be lot many those kind of roles which are being created already into existence or will come in future. So as when computer was invented, there was a shock, there was a surprise that what would happen to the job market, because there were very many clerical jobs which gone away because of the invention or the usage of the computers. Similarly, there would be many mundane jobs which can be automated, are at risk. So what would be my suggestion, or what would be anybody in the working in this area, what would be their suggestion is that you have to constantly develop yourself if you want to sustain in a technology industry. Not only in technology, even it has impact in multiple other industries like telecom and others. So what you need to do, you always need to learn. So you could not think that I have learned this technology, suppose a technology A, and it will serve me my lifetime. That is not going to happen. So you have to be adaptive. You have to learn the new technologies in the whatever comes in every 3, 4, 5 years. There would be change. Today is generative AI. 5 years, 10 years down the line, there will be another technology which is going to impact us. So that is why you have to understand what are the traditional AI capabilities which still can exist. For that, you have to know what is traditional AI. You have to know a little bit of machine learning. So definitely going directly generative AI is also fine. Some people are doing that, but if you have some background of artificial intelligence and machine learning, that is definitely going to help you learn generative AI better. Now moving on, so why this? What are the other advantages? So you already have done some massive pre-training using the huge corpus you had. So there is, for your particular purpose. Suppose you have a problem at hand. For example, a code generation project. You need not spend so much time. The development life cycle has been reduced. So earlier, which used to take say 4 months, 6 months to develop a particular solution for a project, it has now come down to 2 months. So now the expectation from the client, or expectation from your users have become even higher, that they expect that what you have developed earlier in 6 months, you can do it in 2 months or 3 months. So that is also a challenge for you guys as well. So, why this improvement has happened? Because you do not need specific labeling It is a decrease of 10 to 100 times in labeling requirements. Labeling means what is this particular data we have, what should be the target variable, what should be my response variable. So label the each and individual data elements in your data set. So basically what it has done, if it is almost 10 to 100x decrease in labeling requirements, it is actually 6 times decrease in training time. Do not need to spend much time on training the different models. Earlier, it used to take, say, suppose 3 months to train a particular model, 1 month to do a training. Now it is in few days you can do that particular things. So rapid adaptation to multiple tasks with small amount of task specific data. So now you do not need thousands or lakhs or millions of data to train your model. Your model is already pre-trained. I talked about GPT-4, which is already pre-trained with 175 billion parameter. There is a model called Llama, which has been developed by Facebook or Meta, but now it is available open source. It is built on 70 billion parameters, and there are multiple others. So there is a Google model which is coming up, which is developed on 1 trillion uh, parameters, 1 trillion parameters. So you can understand already has extensive knowledge. So suppose you want to develop a particular model for your purpose, you just take one of these foundational large language model and give some example, give some star specific data, and it will be adapted to answer to your particular query. So it is always better to give some example. If you are giving a few example, it is called zero shot to few shot prompts. Few shot meaning basically you are giving few examples. So suppose you have given 5 examples, so it's a 5 shot prompting. So and if you have not given any example, that is called a zero shot prompting. So you have to give some prompt. This is the methodology is called prompt tuning, where you are giving some examples. Now in fine tuning, I'll go into that. There you are not only giving few examples, you are actually training your data with respect to your data, a large language model. But a large language model has multiple layers. Suppose it has, say, few hundred layers, and when you fine tune, it is actually affecting one of the few last layers. So suppose it has 100 layers, then it will affect your last 10, 15 layers, so that the weight gets changed for a particular purpose of your problem. You have a problem at hand that I want to generate test cases for a particular case, say suppose in SAP. So if you give some SAP data and how those test cases are right now, if you give that kind of example, a data set with all those SAP requirements versus the SAP test cases, and then you tune your model. So basically you are changing the weights for the last few layers, and whenever you prompt that can you generate the test cases for this data or this particular requirement document, it will give you much better output than without those fine-tuned models, without those examples. So this is how the large language model works. So traditionally, AI models were doing one particular task. You have one model to do one particular task. Model 1, task 1, model 2, task 2, model 3, task 3. Whereas one foundation model can address any type of task. So it can be multiple tasks, but one single foundation model. So basically, also in case of foundation models, you need not write some specific statistical jargons or specific other things. You can just write in simple English some prompts. You can do some prompt tuning. You can do some fine tuning or you can do some training from scratch. It goes to these foundation models, and you have some proprietary or third party data, and from there you get the response. So this is how it works. So basically, these are the some example use cases. I think we have already covered summarization, classification, content generation, extraction, and question answering. And these are some of the example use cases. In content generation, you can generate marketing briefs, you can generate job description, you can generate reports and presentation, etc. Extraction, you can mask the personal information, you can do some entity audits. In code generation, you can actually develop new code, you can do some app modernization, you can do some migration. In classification, you can do some routing of tickets, you can do what is positive and negative sentiment analysis, and there are multiple other things in the other areas. So these are some of the example use cases. And I talked about the different ways of training. Pre-training, we talked about that this is basically when you are developing the foundation models. Fine-tuning, as I said, adapting the weight for the last layers to adapt output to a specific context. Prompt tuning is basically the giving the different example, and prompt engineering is how you give the prompts, how in which way, in which particular English you should use so that your model understand. For example, you are teaching a student. If you say different jargons and different acronyms to that particular student, he might not understand. But if you lucidly simply explain that if you have to solve this particular problem, mathematical problem, this is step one, this is step two, and this is step three, the student understand. Similarly, when you are giving prompt, you have to have that kind of a clarity given to the large language model or generative AI tool. For example, in ChatGPT, if you write a very complex grammatical sentence, ChatGPT will give you an answer which is not needed for your purpose. But if you give the prompt in a way which is very simple and give the clear understanding, and then the ChatGPT's response would be much better. So that is a prompt engineer job, that what kind of prompting I should give that it will yield in a good result. So now coming to the generative AI or large language models problems. So there can be 12 such different problems. There can be bias because generative AI is pre-trained on various types of publicly available data. So it might have certain bias because those are publicly available and they have their particular response. So you cannot directly use the generative AI always. You have to also think about which particular LLM model is giving you better result. You can then tweak between say, a GPT-4 or a Llama. Then can be a Mistral model, which is a open source model. So there is a link called huggingface.com. You can go to Hugging Face and you can find out what are the different large language models that exist, what is who is at the leaderboard for a particular type of problem. So there are comparisons for a particular specific type of problem, what kind of large language models work. So definitely generative AI has problems like hallucinations. If you ask a difficult problem to these different generative AI tools, it will give you answer because it is bound to answer. That is how it is built. But there can be nonsensical response which might not be useful for you. So that is why these few short prompts, this fine tuning, this prompt engineering are needed to get better response. And you also have to explain to the people. Suppose you are developing something with the help of generative AI, then you have to tell your customer or client that you cannot expect 100% accuracy. Okay, there are bound to be some problems with your output. With time, I can improve something using prompt tuning, using prompt engineering, using fine tuning, but it still there would be say 10-20% deviation from what is your desired output. So currently, any model you take, it is almost 80 to 90% on an average it will give. For some complex problems, it might be only 20-30% accurate. So you have to and you have to ensure whether your particular problem is a specific generative AI problem. But for any type of problem, you can definitely take the help of generative AI, but it might not be always 100% accurate. It can be as low as 20-30% and it can be as high as 95 to 100%. But it would depend on your specific use case, and there are ways to improve the accuracy, but for certain kind of problems it might not still yield the 100% accuracy. LLMs are also being developed. You can understand this particular concept has came into existence for last couple of years, so it is going to develop. So there are concerns like security concerns, concern like transparency. Definitely, these are some of the problems we are working with. So is this an example of hallucination? So there was a David Cox who has earned an undergraduate degree at Harvard University and PhD at MIT. But when this particular question was asked to the ChatGPT, it was giving response that he was born in UK. He passed undergraduate degree from University of Cambridge, although he has passed out from Harvard and MIT. So it found some Mr. Cox in the internet, and it was giving this reply. So it might not be always true. It might give you some responses, but might not be always true. There are safety, privacy, legal issues. That is why companies like Apple, Goldman Sachs, Samsung, who are banning employees from using ChatGPT at work. They feel that their data might be at risk. The OpenAI might steal their data, and then they can reuse it for their purpose. So there are these concerns. So how to improve your prompts? There are multiple ways. There should be completeness, there should be instruction, there can be questions through which you can improve your prompt. So these are the different guidelines. You should provide the context of the prompt, you should be specific, you should have a definitive intent, you should give some examples, you should give some positive and negative instruction, you should try chain of thought, adjust parameters. For example, trying chain of thought, what it is. So basically, chain of thought is basically it should be given some certain instruction one by one. That first you do this, then you do that, and third you do that. For example, if you give a mathematical problem to ChatGPT, more often than not it will fail if it is a complex mathematical problem, because it does not understand how it should solve. But if you give the problem and along with that you give instruction in the prompt that first you should have a addition for this and this, then you should think about how, if it is doing it is in 10 days, how it can do it in 1 day. Then step 3 you should do this. If you give this kind of chain of prompts and chain of thought, then it will be able to deliver. So this encoder, there can be different types of models, LLM models, encoder, decoder only. So for example, GPT-3 or GPT-4 is a decoder only model. I'm not going with for the interest of time. So key aspect of the LLM, there are a couple of things is parameters and tokens. So parameters, I talked about the number of variables in the LLM's neural network, or the number of variables it has used to train itself. More parameters means more complex large language model. Token is every large language model has a token limitation, that you cannot go and use any type of documents and ingest and ask is to kind of summarize or do any prompt engineering on top of that, because it has a limitation of input and output. If you want to generate say, and what is tokens? Token is basically a combination of a number of letters, a number of words used, and the spaces, etc. It is approximately 750 token means it is using your so 1,000 words, meaning so the other way around. If it is 750 words, it is or close to 1,000 tokens. So if you have a document which is having say more than 5,000 words, most of the LLM models would fail. So even if you go to ChatGPT, you will see the similar thing. So GPT-4 is giving it now the 32,000 tokens, but for that you have to have a very high rated subscription. Only the companies can handle that, and most of the other models are having less number of tokens. So you have to be cognizant of how many number of words you can use. That is why new methods like chunking has come. What is chunking? You break your document into different small groups and chunks, and can do your this usage of large language models on top of each chunks, and then you can stitch it back. So there are methodologies like that we are also working on. So these are some of the notable large language models, and what are the parameters in billions I talked about. Okay, so GPT 3.5 was actually so 175 billions, and GPT-4 is 17000 in parameters in billions. And Google had Palm and Lambda, but Gemini AI they have come up with, which is using in the backend almost 1 trillion per parameters. I talked about the Llama model, which has been developed by Meta. IBM has also come up with a model called Granite. So there are multiple those kind of LLM models that exist. I wanted to end with one example using ChatGPT. I'll go into the example very fast. So suppose you have a problem uh, of this particular Python code. You want to understand what this particular code is doing. So I can just copy and paste this particular uh, problem and go to the ChatGPT window and ask, can you please translate this code into business language in plain English.
Excuse me, sir. Sir, your presentation is only visible, not the window of chat.
Oh, okay. Let me. Is it coming now?
Yeah.
Can you please translate this code into business language in plain English? I give this and then I paste this. It is explaining me that in plain English what it is. So it is basically a function named compute salary and calculates the gross salary. Within the function, it calculates the house rent allowance, it calculates the DNS allowance, the provident fund, and returns the calculated gross salary. So this way it explains. So a person who is not very conversant with that particular code and wants to know that what this particular code is talking about, you can very easily use your generative AI tool to do that. So this is just one example I thought of explaining. So with that, I'll end my discussion.
Thank you, sir. Thank you so much. That was really an wonderful and insightful session about the generative AI, and you have given an entire nutshell of generative AI, sir, in detail. So definitely the participants might have enjoyed this. Sir, with your permission, I will just pose the poll questions. The participants can take up the questions. After Q&A, we will be responding to the poll.
Sure.
Participants, the poll question is open now. You can take up. In between, we will be taking up the Q&A, which has been already received in the chat box. So the first question is, what do you think about the specific reason why Apple has pulled out of self-driving car, and also why the company Cruise has recalled almost all of its self-driving cars? This is the first question, sir.
Is it a question to me?
Yes, sir. Yes, yes. The Q&A from the participants, sir.
Okay.
The first question is, what do you think about the specific reason why Apple has pulled out of self-driving car, and also why the company Cruise has recalled almost all of its self-driving cars?
Right. So basically, there are a couple of challenges. So first of all, I'll talk about the investment. So definitely, a lots of investment that is needed. There were problems also while doing this kind of research. Suppose I can give one example which is coming to my mind, that there was a red sun. So it was a setting sun during the afternoon or evening time. The AI machine was trying to identify that, it thought it is a red signal. So, so you can understand why while developing your cars, there would be some flaws, that how to differentiate setting sun versus a red signal. So whenever it was seeing a red setting sun, it was stopping the car, although it was supposed to go along. So there are some problems while developing this kind of autonomous vehicles. For example, you talk about the Indian roads. So we do not follow any lanes. There are cows and cattle everywhere at the road. So how this particular autonomous vehicle would be successful in India? Definitely it can become successful, but it will need more time. If it is working fine in US in 2030, perhaps in by 2035, it should be available to India. So that is why there were problems with respect to this kind of various functionalities. That is why some companies had recalled cars, and Apple was not very successful with respect to the initial testing. That is why they had pulled out, but there are multiple. That is why I kept the example of Google. Google is still working on it. Tesla has already reached a very good level of level 3. It has crossed. It is doing researches at the level 4. So it will. There would be some companies who will go away, and there would be now new companies who would come up to in this bandwagon.
Yes, sir. That was really a thoughtful answer for the participant who asked the question. So, with your permission, shall we take one more question, sir?
Sure, sure.
Yeah.
So I would also like to highlight that there are multiple regulations are coming up. So I wanted to talk about a web series called Guilty Minds, which you can see in Amazon Prime Video. You might not be very good at Hindi, everyone, but you can go through the subtitles. That it is on what would be the effect of AI or Gen AI on human beings, and how the legal rules and regulations should be into place. There were plagiarism, like people were combining various music tones to prepare one particular music. So there would be rules for that. There is autonomous. There was one episode of the web series which is on these autonomous cars. So each one episode is on one particular problems of AI and Gen AI, and how we can handle it legally. So there was a question of deep fake in the previous session. So definitely this kind of problem would bound to increase. So how we can do reduce that? We can reduce that through different legal norms. So basically, if you people do not have fear of thought, then they will continue to do that, because your pictures are definitely available. For think about the celebrities, they have to give their pictures in the internet, in the Twitters and everywhere. So you cannot reduce that, but you can reduce this kind of crimes with very strong legal rules and regulations. Yeah.
Yeah, so that's very interesting to note what are the things which is happening really. So the next question is, can you please explain what are the computational resources required for training and deploying Hugging Face generative AI models?
Yeah, so basically, if for any kind of generative AI models, you need to have GPUs. Simple CPUs would consume everything. So you have to have very good processing power, and that is why you need GPUs to run your models. When, especially if you are talking about at least any use case, a client, simple client use case, we are having different GPUs. So definitely you have to use instead of using any on-premise things like software in your desktop or anything, you should use the cloud options. That is why every cloud company has come up with their own generative AI system. If be it Google, be it AWS has its Bedrock. Then your Microsoft has taken over OpenAI. Google has their own Vertex AI, as well as they are coming up with Gemini and other things. So you need, it consumes so much of processing that it should be done better in a cloud environment.
Yeah, sir. True. Thank you, sir. Thank you for your answers for all the questions we have give asked to you. And participants, due to the next speaker is also in line, so we will be directly moving to the session 3. Thank you, sir. Thank you, Sanmitra, sir.
Thank you.
So now it's time to move on to our third interesting session, strategies and frameworks for AI governance. Dear participants, it's my privilege to introduce Ms. Anushka Burkar, a dynamic professional in the field of data and AI solutions, currently serving as a brand technical specialist at IBM in Bangalore. At IBM, Anushka has played a key role in accelerating clients' data journeys. Prior to this, her experience as a pre-sales analyst at Dell Technologies and as an assistant system engineer at Tata Consultancy Services showcases her technical powers and dedication. Anushka holds a bachelor's in computer science from Rajiv Gandhi college and in a continual learner with certifications in requirements, elicitation and analysis, information storage and management, business analysis foundation, and Lean Sigma Great Belt. Her internship at Reliance Jio reflects her versatility and industry experience. Ms. Anushka embodies innovation and expertise in data and AI solutions. Join me in extending a warm welcome to gain insights from her rich professional journey. Please welcome Ms. Anushka. Let's invite Ms. Anushka for giving her expertise on strategies and frameworks for AI governance. Thank you for being us with Anushka, ma'am. Welcome you, ma'am.
Thanks a lot. I hope my audio is okay
Yes,
and you
ma'am.
guys can hear me well. All right. Thank you. Thanks for that lovely introduction. I'll straight in jump to the session. I'm a little short on time, so I don't want to, waste any more time. Let's just get started.
Yeah, ma'am.
Sure. Just let me know once my screen is visible.
Yes, ma'am. Your screen is visible.
All right. So I did hear a lot bit of Dr. Sanmitra's session, and I think it was a very, very informative session. Now we all know how LLMs are built, what are they really. So I wanted to focus on this LLM from a slightly different angle, that how do we make them more responsible, more transparent, and how do we really govern them, right? Because it's not just that you train a model and you start getting answers from it. As an organization, as enterprises, it is really important that you can trust it, that you can use it, and all of that can happen when you can really govern those models, right? So without governance, that trust, that explainability, all of that cannot really happen. So before I move and I tell you in details about the governance aspects, a little bit of context settings in terms of what are these risks really that are associated with the large language models. I'm sure all of you day in day out hear some kind of news with respect to the current AI landscape, right? There is some lawsuit, some regulation, somebody is being sued, somebody is giving you wrong answers. So a lot of risks are really facing us, right? It's not just on us individuals that our digital identity could be exposed, our personal information could be exposed, but as an organization also you really face the risk of losing your credibility and your reputation, right? So you cannot really have all this at stake when you are a big enterprise. So then we need to focus on what are these risks really, right? These risks, now I can yeah, now my screen's better. So the risks, can I have just categorized them broadly into what are the risks associated with input and then with output. As we just learned, a lot of data goes into training these large language models, right? So if you do not use that large amount of data, or if you use biased data, then your model is at risk of being biased in giving its outputs as well, right? It could be biased towards gender, towards geography, towards some strata of the society. It could be any kind of bias, really, right? And then there are these data poisoning attacks. So when data engineer, when data scientists are training those models, they are prompting those models, they could expose some false information into those models, right? So then your model again is at risk. It could be poisoned with wrong data, with maybe personal information, copyright infringement, and all of those issues can really happen when it is not trained and when it is not being used in the right manner. And in the inference phase as well, as I just mentioned, the prompt could be leaked, it could be wrong, there could be certain legal issues with respect to not using the right kind of data. So with large language models, or for example with any AI ML models, really it really follows the policy of garbage in, garbage out. So whatever you put into the data, into the training, is what you're gonna really get as an output, right? So if you've entered biased data, the output, the results are going to be biased as well. So the content which is generated, that could be again biased. For example, let me just take here an example of a bank. If the credit department, if they've used small section of data, right, and then they end up using that model, so then they could be really lending out loans or credit cards to maybe a certain strata of a society, maybe a certain gender, maybe a certain geography. So some marginalized section which was not represented in the training of data, they could be left. Now that is a huge bias. The banks cannot afford to really do that. So one has to be really sure that the data which has gone in is bias free. And then there could be performance disparity, copyright infringement, so many legal issues that we face today, really, right? So whatever has been wronged during the input phase, that will definitely show up as an output. So then, of course, these challenges, Dr. Sanmitra also highlighted that there could be transparency issues, diversity issues, environmental impact. That is also a really huge topic, right? Because these large language models are so huge, they require a lot of compute to run. So there are huge environmental impacts also, that whether you really need a model which is a 13 billion, which is a 70 billion model to do small NLP tasks, or can you use relatively smaller models? So those kind of decisions everybody needs to take, and everybody needs to keep in mind that there are these risks which are associated. So what do you really do about it? How do you go about these risks? Yeah, just one more slide where these regulations are very are coming closer, right? Every country, every state in the US, there is a new regulation which is being laid out every day. In fact, in India as well, we've heard about the DPDP bill, the data protection bill, right? And Niti Aayog, that is also working on the establishment of strategy for artificial intelligence. How are we as a country which cannot have the last mover disadvantage? We really need to make it an advantage. We've always heard about first mover advantage, but as in India, we could be behind those developed countries. So we cannot have that at risk, right? We should turn around to make it into a last mover advantage. Those are the things that organizations, that government are really focusing on. So when you think of using these large language models, you have to think about so many other things as well, right? It's not just about hiring the right data scientists and getting them to build the right model. You really have to think holistically in terms of how, as an enterprise, am I making a model which can be trusted and which is governed at each step, really. So these are some facts, some those surveys which were run by Accenture, by PwC, by KPMGs, and these are the numbers, and these numbers are really high. Right? These are the numbers which have come out because today everybody wants to be ensured that there is no risk in using these models. So the 90% of leaders are concerned that the operating costs could be up by 30% because with huge opportunity that we see in LLMs, there are huge risks as well associated with it. So these numbers are really high there, where everybody is grappling with these challenges. That how do I manage? How do I govern? What do I really do? So just highlighting that it is everybody's business, not just organizations. Even we as individuals should be really careful about what kind of data are we exposing to the model when we use those models for everyday questioning, answering, and how are we trusting it? Are we taking all of it and just trusting it blindly, or are we able to regulate it, or are we able to trace its source? How do we trust those answers, and how do we ensure that we don't leak our personal information onto these models? So it's not just organizations, it is everybody's business that we need to be sure that these risks are covered and we are also aware of these risks. So then I spoke so much about risk and what can go wrong. Now everybody could be scared about that. But let's focus on how can we make this platform now trustworthy, because AI is everywhere, generative AI is everywhere. We cannot escape it, right? There is no development without being hand in hand with the latest technology. So now we can focus on the how to get it done, right? How to make these platforms trustworthy. So there are a few questions that all of us can ask. So number one being, how was it trained? So with what kind of data went into the training? A model that was trained on a Wikipedia crawl, can it really be trusted? We know how credible source of a Wikipedia is, right? So how was it trained? Which data really went into the training? Was the material, gotten rid of the PII, the copyright and the legal issues? Was that data removed or masked, and what really went into the training? So once you ensure that your training data is clean, it is secured, that is how you really begin to trust that model. Then can it detect and minimize bias and hallucination? So of course it is a model, it is bound to be sometimes wrong, it could be biased, it could be hallucinating, it could be providing wrong answers. But then what do you really do to detect that bias and then correct those bias, right? How do you minimize the risk when it comes to giving wrong answers or hallucinating or being biased? So you should really be able to say that I am able to monitor, I know when my model hallucinates. So these are the certain thresholds that I will put in place. When it crosses those thresholds, I'm going to get an alert and I'm going to make sure my model does not bias, it does not hallucinate. And along with that, is that model transparent? Whether it is a black box of AI where we do not know anything about what went into it and how is it used, what was the training, anything, you don't know anything about it, or whether it is transparent, that you know what kind of data it was trained on, and the answers that it generates are explainable, right? You are able to explain, you are able to give it a reason that this is my generated answer and this is the reason behind it, or this is the source of truth behind it. So it needs to be explainable as well. And then of course it should support those regulatory compliances. If you are in Europe, if you're in US, if you're in some state, you need to follow all of the regulations that have been laid out by the government. So it should support all these regulatory compliance, privacy issues, infringement issues and whatnot, right? And then it has to be really safe, right? Because when your model, say for example, gives wrong answer, then who is responsible, who has the control over it, and can you ensure that that confidential information is not given out? So you need to put certain guardrails in place, you need to put certain safety measures in place, that I am making sure that it is safe, and these are the guardrails that I've put into the place. And then lastly, when you have gotten all of this right, you also need to have that model to be flexible, right? Can it be deployed anywhere? Do I have to arrange hardware for that? Or can I use just it as a service? Is it available on cloud? Can I customize it? You have given me a large language model, but I have a very domain specific use case. For example, in pharma itself, right? How many models do you see today which are specifically trained on pharmaceutical data? So you can take these large language models and then train it with your labeled data, with your domain specific data, and that's when you can fully utilize that large language model for your domain, for your specific use case, right? So it should be customizable as well. And then is it can I integrate it with other applications as well? For example, if I want to feed my source of documents, my repository, my knowledge base, can it integrate with that data source platforms? Can it integrate with my front end platforms? And how do I really make it a part of my ecosystem instead of having everything new in the place around the model? The model should fit in my ecosystem, right? So it should be customizable in that sorts, that I don't have to change everything. I'm just introducing one element into my ecosystem and it is integrable into my ecosystem as well. So those are the really things that you need to think about when you think about being able to trust a model, right? These are certain parameters, these are certain guidelines that you can follow, and you can ask yourselves, and you can really ensure that whether that platform can be trustworthy or not. So, of course, AI governance and all of those things that I spoke about, it's easier said than done, right? It is complicated because what we're saying is that you trace the documents, the origin of data, associated models, metadata, the entire data pipeline needs to be audited when you think of governing, right from the source to the output, everything needs to be governed. Now that is easier said than done. Your documentation, which techniques did you use to train your model? What were the metrics? What were the hyperparameters in the testing phase? You need to ensure that all of these things are audited, and not just once, not just before making it go live, not just before production. Even after production, you need to continuously monitor these things. So now with enterprises, one size cannot fit all, right? One company could be using certain other frameworks, certain other technique, other could be using something else. So one size cannot fit all. So this lack of standardized tools, platforms, this also results in a lot of manual work. One has to do a lot of manual work in ensuring that you get the right people in place, that you get the right data in place, and so many things, right? And then of course there is a certain executive layer which needs to be responsible. They need to be the approver of that. So that communication gap also really bothers. There is a large gap between the right stakeholders, the data scientists, and whatnot. So it's a very complicated scenario when you think about it, really. And when it comes to governing, and when you think of a tool, you cannot think of two separate tools for your two separate models. For example, your traditional AI and ML models will be governed differently. Your Gen AI models will be governed differently. Now again, that is a lot of complexity. That is a lot of cost as well. You follow certain tools, certain guidelines for one and the other. The value proposition really cannot come if you think like that. You cannot work in silos. So some of the complications that everybody, all the organizations, all the enterprises that face are these complications. So then, what do you really do about it, and what is IBM's value proposition around it? So IBM has launched Governance which is a really powerful toolkit which can do all of these, right? Which can help you direct, manage, monitor all of these AI activities, be it traditional data science, be it generative AI. It is a toolkit that ensures that all of these risks, all of these complications are simplified for you, and then you get sort of one thing for one toolkit for all sorts of activities, for all sorts of monitoring, right from the data to the post production. You are ensured that one platform will be able to do all of those things. Now, before I get into more details of what's next governance, I just want to spend a little bit of time on the AI life cycle itself, right? Because you're saying you want to govern everything, but there are so many complications. But let's really take a step back and understand what is the flow really? What does it look like when it comes to these building these AI models? So first thing could be, there is some executive who's just come to the data scientist team and they are asking to that we have a really eureka moment here. We want to build this use case. So get started and build that model for me. It could be a Gen AI model. It could be a traditional AI ML model. So it really starts from that when you get that idea or get that request from your executives that I need a model to do so and so for my organization. So then you start building that model and that's stored in your model inventory. So you've captured all the facts and you've captured all the data and you've captured everything that has gone into building that model. So that becomes the first step, and that becomes the model inventory of the sorts, right? And then second is the risk governance part. Now that I have a model in place, now I can really start thinking about the governance, right? So what can you do? You need to ensure that the facts around the model, the data which it was trained on, which training technique was used in case of LLMs, what was the prompt that was used, who is responsible for training the model, if there's any other metadata that I should be aware of, all of those things are in place. So then you can think about governing those, right? When once you know what has gone in, what has been followed, what is the framework, that is when you can start governing it. That is when you can start monitoring it. And so the last part is the evaluation and the monitoring. Now that you have the model, now that you have all the facts around it, now you can really evaluate and monitor it, right? Is it accurate enough? How far along the line does it start to drift? Is it biased? Is it able to explain the source of its answers? So all of those things then become a part of your evaluation and monitoring process. So now that could be again deployed over any platform, right? It could be deployed over IBM, AWS, or whatever the platform that you have used. Your tool should really be able to govern and capture all of this. It should be platform agnostic, which is what Watson X governance is really, right? So then I spoke about the life cycle, but just capturing a few necessities around it, right? How do you monitor and evaluate, right? How do you ensure that it is fair? How do you ensure that all the personal information has been hidden or masked or not being used? And then you explain the predictability of it, you explain the output of it, right? Instead of data scientists doing all of this manually, it should all be automated. There should be less and less of manual work and more of automation that should go into the toolkit, right? And then you have to gather all the facts at all the stages. It's not just when you start building it, even after post deployment, as I mentioned, all the facts, all the matrices should be captured, and again, all of that should be automatically gathered because you cannot depend on so much of manual work. Your data scientist cannot spend its time in building reports and capturing all this data and doing all of these tests instead of really focusing on development of the model or the idea of the next use case and things like that, right? So it should be all automated. And then once you have those, In an organization, in an enterprise, you really need to follow a lot of workflows. There has to be one person who is responsible, so he needs to approve that, then he can take it to the leadership, and then everybody should have a view of the model, right? Now, a leadership or maybe a chief risk officer or a chief compliance officer cannot spend their time in reading all the facts. It should be a high level view for them, whereas it should be a lower level view for the person who's taking on this project. So now all of these should your toolkit, your tool should be able to do all of this at different levels, and it should be able to do all of this simultaneously, right? We cannot depend on different tools and different places to do all of this. This all should be a part of one platform, which is what WatsonX.governance really focuses on. So, like I said, it can manage the entire life cycle, it can manage the process, it can capture all the facts, and be it any use case, be it any industry, geography, technology, all of those things are really taken care by WatsonX.governance. Now I want to move on to the demo part of it, where I want to show two things as part of the demo. One is the model evaluation, and second is the model monitoring. So I'm gonna stop sharing and get those videos up. Just give me 1 second. Can you see my screen now?
Not it, ma'am. Yes, ma'am.
Is my browser visible now?
Yes, ma'am.
All right. So this is a demo and an example of how it is monitoring, evaluating, and documenting all of those things around the model. And can you hear the audio as well? Just give me.
WatsonX.governance features automated evaluation
Can you hear the audio?
Yes, it's clear.
capabilities that can help streamline and standardize the performance measurement of prompts and models. Let's see how it works. With just a few clicks, you can use WatsonX.governance to document your prompt engineering activities. Simply navigate to the use case inventory and select a use case. WatsonX.governance automatically captures key information about model development, including the methodology, the model details, and the prompt parameters. From here, you can check that the prompts are performing with suitable accuracy and that they're not producing potentially harmful or inappropriate content. An intuitive wizard tool provides instructions on how to initiate evaluations. You can choose from a wide range of metrics, including those associated with common generative AI tasks like summarization, question and answering, retrieval augmented generation, content generation, and classification. After you've selected your desired metrics, upload test data containing the known gold standard or ground truth. Then set your input and reference output. Once the wizard is run, you can quickly view the documented metrics in a fact sheet, which also contains key information like use case name and task type. To see how using model evaluation and documentation can drive responsible, transparent, and explainable AI workflows, sign up for a free trial of WatsonX.governance.
And just one more minute I'm going to take, and then I'm going to hand it over to the next speaker. Just give me 1 more minute, where this is a demo of model monitoring.
Sure, ma'am, sure.
WatsonX.governance helps you monitor AI performance so you can mitigate issues related to drift, quality, and safety metrics. Let's see how it works. Once you've tested and approved an application for production, the monitors are enabled and will generate alerts when appropriate. For instance, this drift alert indicates that model performance may have deteriorated, a common occurrence as data changes over time. Further investigation is warranted. In the impacted app, the prompt is generating summaries of inconsistent style and length. You can quickly pursue remediation by re-engineering the prompt, selecting a different model, or re-evaluating and redeploying. You can easily establish alerts that are triggered when drift thresholds are breached or when undesirable language or personal identifiable information is inputted to or outputted from a model. Alerts can also identify when there are changes to metrics like data size, latency, and throughput. Model monitoring is logged automatically and integrated into a fact sheet, delivering a comprehensive performance and risk management view across the app development lifecycle. To see how using model monitoring can drive responsible, transparent, and explainable AI workflows, sign up for a free trial of watsonx.governance.
Alright, so those were the demos that I wanted to show. If I'm sorry, in the interest of time, I will not be taking the questionnaire right now, but of course, Vinod and the team can hand over the questions to me. I can address them, and if there are any interests around this area, governance, large language models, or even IBM's platform, you can reach out to me. You can get my contact details from the New Biotics team, and I'll be happy to help you. I'll be happy to show more demos, or even have a discussion which is more in depth, which is more directed towards certain topics. And that's it from my end. I hope I was able to give you some key bits that you can take and think about when it comes to risks and governance around these large language models.
Yeah, ma'am, thank you. Really, thank you so much. In your tough time, you have given away this session in a beautiful way. And I just want to say you that it is very simple, and you have given the AI governance complications in a beautiful manner with examples and a demo too. So really, thanks for that, ma'am. So dear participants, as per the request from the speaker, we are not taking up any Q&A for this session, and we can directly move on to session 4. Thank you, Anushka, ma'am. Thank you for your time. Thank you so much.
Thank you so much.
Dear participants, finally we came to our webinar's most interesting and exciting session on revolutionizing healthcare through generative AI. Dear participants, it is indeed an honor to introduce a distinguished professional dedicated to groundbreaking research and advancements in medicine, particularly in cardiac surgery and non-invasive omics tracking. Our esteemed chief guest for today's event is Dr. Ravishankar Polishetty, cardiac surgeon, Ayurvedic researcher, data scientist, and founder and CEO of Sai Ganga Panikya. Dr. Ravishankar is not only a physician but also a presenting doctor at Poly, the world's only non-invasive omnistracker and digital doctor assistant. With over 12 years as the director of R&D at Sai Ganga Panikya, he has played a pivotal role in contract research, Ayurvedic research, drug discovery, and API development. As a cardiovascular surgeon, Dr. Polishetty achieved a groundbreaking feat by demonstrating subtotal regeneration of heart tissue in post-MI animal models, a first in the field. His impressive portfolio includes 4 patents, 29 filed, and more in progress. His commitment to learning is evident in his educational journey, including residencies at the Bakalova Scientific Center for Cardiovascular Surgery in Russia. Dr. Polishetty continually enriches his knowledge, participating in programs at esteemed institutions like IIM Ahmedabad and IISc. Throughout his career, Dr. Polishetty has held leadership positions including research consultant at Johns Hopkins University, senior consultant, cardiac surgeon at Umani, and founder CEO at Panacea Nova Incorporation in Toronto, Canada. In inclusion, Dr. Ravishankar Polishetty's career embodies excellence in research, leadership, and medical innovation. Today, we have the privilege of learning from a true visionary and leader. Please join me in extending a warm virtual welcome to Dr. Ravishankar Polishetty. With great honor, let us welcome Dr. Ravishankar Polishetty to take the platform for the much anticipated topic revolutionizing healthcare through generative AI. Welcome you, sir. So it's mute, sir. It is in mute, sir.
Yeah.
Yes.
Thank you very much for this warm welcome, and I see that a couple of them already slept. I'm just kidding. So,
Yes.
thank you,
But it
really
is the most
appreciate
interesting session, sir.
it.
We expect.
Yeah, I'll share my screen. So I'll make it as interesting and as precise as possible. But I'm not good at short lectures. I always had this trouble of not being able to because this is a very vast subject and encompassing data science, Ayurvedic research, allopathic medicine, formulations. It's a very vast. I mean, it's 545 hours of lecture for doctors, MBBS, I mean, consultants, Ayurvedic doctors, and so on. So I'll try to bring in very pivotal points of how to actually understand the body. How did I understand the body in the last 32 years? After immersing myself in both modern medicine and also ancient scriptures, learning them in original Sanskrit, and my journey that led me to Sri Sathya Sai Institute of Higher Learning, and I worked there as a consultant cardiologist and screening cardiologist. Seeing about approximately 200 patients every day per day, and for over 2 years, treating more than 28,000 patients, finding an interesting data model, and I think, and I'll take the help of Dr. Anushka, who was here, to validate the model that I developed. But let me, get to the next step. So this is what's my close friends. And are you able to see my screen, please?
Yes, sir. It's visible, sir.
All right. Okay. Perfect. So, how did my own medical practice evolve, and how did I stumble upon data science and Python programming, and then develop this model, and then I'll just try and quickly give this just quickly here, friends. So, why Ayurveda, friends? Why did I look, the other side of the coin? While allopathy is the most popular, most dominant, and if I keep saying, I keep saying that this is not an Ayurveda versus allopathy debate, but then together, you get a better understanding of the science of life. So it all started with at the age of 19, I was really scared looking at the side effects that several of these pharmaceutical drugs could cause. That was a very amateurish look into the understanding the pharmacology. But then I stumbled upon. I started. I mean, as I said, and I kept reading this ancient scriptures since my childhood, and then that really helped me. Because it was always said that Yanna Bharate, Tanna Bharate, and so on and so forth. So I started reading the scriptures. I really understood that the ancient science. See, now we know. Okay, let me just give you a quick example. See, today India is the diabetic capital of the world. But what is diabetes? For which you have four different standards given by four very powerful, data-driven organizations in the world. The American endocrine, there's something called blood glucose that you all measure, right? When you say diabetes, you definitely go and measure blood glucose. But then, did you know that different standards are given by different organizations, and all are data-driven? Endocrinologists are saying that your HbA1c, which is the average 3-month blood glucose, should be below 5.5. The American Diabetologists Association is saying it should be below 6.5. Now the American College of Physicians is saying no, it should be between 7 and 8 and never below 6.5. They're apparently going at loggerheads with the diabetologists and the endocrinologists. Now, why did they say that? Because they did this study, and in certain study called as Accord, they figured that when a diabetic patient is also heart disease patient, ischemic heart disease afflicted patient, then if you push his glucose levels below 6.5 in the blood, 1 in 3 patients died. And now the American Veterans Affairs Diabetic Association is saying, your HbA1c, our veterans are doing good with between HbA1c is between 8.5 and 9.5, and our people, I mean the veterans aged between 50 and 78, and certain cohort of individuals also, at different age groups, they essentially can't tolerate anything below 7. Anything below 7 is hypoglycemic for them and triggers several other problems in them. So friends, the question is, what is diabetes? Who is diabetic? According to what are you diabetic is the biggest question. So for which I started, not just this, did you know that your good cholesterol, excessive good cholesterol is also causing heart attacks? Low bad cholesterol is also causing heart attacks. See, now we don't know how to treat the patient, literally speaking. That's why it's a very precarious situation. So that's when I started looking at the ancient scriptures, and I figured that all the data that we generated now, I'm not saying all the data that we generated now was known to them, but then it appears beautifully, everything was classified. They came up with labeling of the data in the language of data science. They labeled the data into Vata data, Pitta, and Kapha data, and based on which all your metabolic pathways, physiological pathways, immunological pathways, cellular pathways, subcellular proteomics pathways, all could be at a broader level, at a higher level, could be labeled into 3 groups, into Vata, Pitta, and Kapha data. And at the next level, you end up with essentially 15 labels. There, because each of these Vata, Pitta, Kaphas are classified into 5 different groups. So you have 15 different classes or clusters of in the language of data science. And then you apply these 15 clusters interacting with each other in each of the 7 tissues and in all of the 42 organs. That is the science of Ayurveda, and that's for which I developed a mathematical model, friends, and using AI. So this is quickly mentioned about this. So I'll not go deep into of course after Karthik and Dr. Sarkar and of course Dr. Anushka, their lectures, you don't need any intro into generative AI. But as a doctor, I'll give certain aspects, certain different facets of how I visualize data and how in the language of medical science. Okay, so I'll just give that. So friends, did you know that misdiagnosis actually caused caused an effect where doctors were the number 3 in leading number 3 in the causes of death? Did you know that? It is a fact, friends, unfortunately, because today, at least in the US, 800,000 Americans die every year. In the whole world, about 22 million, 2.2 million people die because of missed diagnosis, missed interventions, and so on and so forth. So, and luckily, WhatsApp group professors, YouTube lecturers have really helped medical practice, because despite lacking formal medical education, their insights have influenced healthcare delivery. And you know what? WhatsApp university professors occupied the number 3 position in killing people, because in our own institution, you know what? Every 4th kidney failed patient is an afflicted WhatsApp University knowledge-based professor, patient. And the YouTubers definitely, they read for 10 minutes, make a video for an hour, get million views, and they're happy. But then patients are unhappy. Doctors are unhappy. But then, there's a very sarcastic humor that I didn't want to. But then this is a real problem, friends. YouTubers have pushed doctors. The number 1 cause of death is heart disease. Number 2, cancers. Number 3, WhatsApp University professors. Number 4, YouTube professors. Number 5, lung diseases. Number 6, come doctors now. That's the state of ignorance in the whole world today. And how will AI help in this landscape? Because as I mentioned, diagnostic errors pose a significant risk to patient safety. Is AI helping in diagnosis? Absolutely, yes, friends. Absolutely. I'll show you some interesting, insights into how, let's not even go to Gen AI, friends. Just simple PCA, I mean, the principal component analysis based, image processing and CNNs and in some instances RNNs are also have revolutionized, medical imaging and diagnostics, friends. Uh, yeah, sorry. And also, the AI for early detection, predictive analysis, and also, is helping in streamlining healthcare processes. Today, if a doctor, talks to the patient, he keeps on jotting down. He doesn't look at the patient, unfortunately. With the AI tools, I see a lot of time. I could spend more time. Of course, we improvise the process of patient consultation, and we spend more time with the patient in explaining him the problem. But then, streamlining the healthcare processes definitely the AI has definitely helped, and improving patient care definitely has. These are the areas I'll quickly touch upon, and then I'll just show you. See, what is a retinal imaging is going to show you. Retinal image is going to show how your eye performs. That's what we are taught at least. That's what we know. But did you know that retinal image is now with the help of AI? There was a article published in Nature. Intel, along with the NAC guys, they developed a model, AI-based model, and published in 2022 how retinal imaging could actually predict the risk of heart disease. That's amazing. Risk of heart attack and stroke, heart's calcium score, which is very, very important to actually see if a certain person would have a heart attack or not. This was again published in the Lancet Digital Health version in 2022, friends. And diabetes and blood pressure control. How do you monitor diabetes and monitor blood pressure control? How do you monitor diabetes? Already know, but then AI actually is helping in not only monitoring the way diabetes is being controlled, but also detecting Alzheimer's just from your eye, the retinal image, detecting or predicting Parkinson's, neurological insights with a precision of more than 97%. It's amazing. So. And also, just recently, it's about 6 months ago, Joe I published a groundbreaking study in Nature. Now he trained his model with more than 1.6 million retinal images, and it really detects all diseases like heart diseases, heart attacks, strokes, Parkinson's, and glaucoma, and more. This really revolutionary. And then we all knew that ECG is to measure your electrocardiogram, is to measure your electrical activity coming from the heart. That's all we were trained. I'm a cardiologist. And did you? And I was astonished to when earlier, I think we were talking about it in 2010 that a certain possibility of ECG could be used to determine age and sex, and it became a reality in 2019 when it was published that age and sex could be determined from your strip of ECG. And AI is also able to predict your race based on the ECG pattern and the cardiac function. Ejection fraction, friends, is something that you detect when you do a Doppler echocardiography. It's called. And did you know that ejection fraction could be detected from ECG? And the model is trained from at least hundreds of hundreds of thousands of echocardiograms done in the last 22 years. They're all stored in the US, and then they were able to come up with ECGs. They were used to train this model, and then Nature Medicine published this in 2019. Heart pressure sensing from ECG, enhanced cardiac assessments like atrial fibrillation, stroke risk, and so on and so forth are being predicted right now. Disease prediction, difficult diagnosis prediction, anemia and hemoglobin levels from your ECG, diabetes and the pre-diabetic prediction from your ECGs, chest X-rays, again, the RSNA, the Radiological Society of North America, has done a wonderful job. They have more than 70 million radiological chest X-rays, through which they're also able to predict your race with ethical consideration. I mean, they're able to predict everything, with the help of your X-rays. That's amazing. So as Dr. Sarkar and my peers just mentioned, Karthik and also Dr. Anushka, they mentioned, see, the problem I stumbled up with the Gen AI models that are being developed is that you don't have appropriate models, or you don't have improved outcomes. Ultimately the purpose of any healthcare technology is to improve your clinical outcomes. So that's when I stumbled upon reading these books on data science, and then I was good at maths, and so I understood the logic behind all these encoders. And then I'll not go deep into this BERT and transformers, because that was a part of my I thought I'll share my views on that. But then the basis of neurophysiology, friends, for my non-doctor friends here, or doctor friends if they are here, most of these neural networks are built and are inspired from neurophysiology, friends. What happens is, when I'm talking to you, when I'm talking to you, the sound is incident on the ears. Inside the ears, on the other side of the tympanic membrane, I mean, the tympanic membrane vibrates based on this sound that is incident on the tympanic membrane. On the other side, you have the auditory receptors. They sense sound, and they convert this mechanical tympanic vibration into an electrochemical message at the site of this free nerve endings. All right, so there are several endings. You have similarly you have the rods and the cones in the retina that sense light. Your tactile receptors on the skin, they sense the touch. At every sensory receptor, this external stimulus converts itself into an electrochemical message. A certain pattern of electric current is generated. So it goes all the way to the nerve, and at this stage, are you able to see my cursor? Let me put the laser pointer. At this stage, sometimes there's a feedback mechanism, and sometimes it goes to the feed forward mechanism. I'm trying to explain you the origin of the transformers from this paper. Attention is all we need. Very interesting. How the neurophysiology was literally replicated into a machine-based model. That's amazing. But because I knew neurophysiology, it was easy for me to understand. And so what happens is, this electrical stimulus goes all the way to the brain. The brain analyzes the information and sends back signals, again in the form of electrical message. Um, okay, I just showed how this electric current is generated. The sodium, depending on at this stage, you have the resting membrane potential, and when an external stimulus, acts upon a cell, sodium ions move into the cell, and slowly the cell, inside the cell, it gets charged up with sodium positive ions, and then a certain I don't want to go deep into this, but then the external stimulus is packaged in this way. This is called as an action potential, and this action potential is then I just mentioned that it travels all the way through the neuron, either to the you have the spinal cord, where you have certain conditional reflexes getting looped in, and then spinal cord essentially could also give feedback, and then or it could respond, and then the body automatically responds without the brain knowing it. Sometimes this response is so complicated that the response is sent to the brain. The brain analyzes the centers in the brain, analyze the information, then send back a afferentation through which you end up with an action. So this is a quick summary of what kind of response is, how the response goes all the way to the brain, and we respond essentially. Now, there are several receptors. I don't want to talk about it. Let me then go further. So this is where I said, sometimes this response that is going all the way through the spinal cord, it loops and then comes back in the form of an afferentation, and many times it goes through the brain. These are the centers in the brain. The brain centers essentially, respond accordingly. And what you do is, as if the response needs if you need to act quickly, then the response is the electrical activity of the brain resides in the brain for about in the cortical centers for about over 5 to 7. I mean, about anywhere between 5 and 7 hours, and then the body responds immediately, and then it's like the RAM, random access memory of your laptop, and but sometimes it gets into the deep into the memory because if the information or the response has to be stored, the brain produces proteins, and these proteins are the ones that store your memory. So the short memory and the long-term memory are essentially, applied here. This also is again translated into a neural network that really inspires all your actions. That's pretty much about how the body responds, and it's all the way the sensors, the sensory receptors perceive the information, send it to the brain, and the brain responds back. So I wanted to quickly talk about the bird transformers, but it was a lot about it was talked about, so I'll quickly skip this. So what we did was, so friends, we are able to accurately predict the disease, right? With the help of with the help of these AI technologies, we are able to better predict, because millions and millions of patient data is being used to train the model, and the model, how the model is trained, and Dr. Sarkar, they've already mentioned about it. So you have a training data, you have the testing data. Initially you have about 90% of your training data with right responses. You use that data to train your model, then use the test data to validate it, right? That's I don't want to go deeper than this, but that is more than enough. But then, so with this, your accuracy, you're becoming better than the best, or you're becoming almost on par with the best cardiologists or neurologists across the world. Definitely, I cannot vouch at this stage whether you'll become better than the best. I don't think so, because just like our Dr. Anushka mentioned, if you put in garbage, you'll automatically come out with garbage. Garbage in, garbage out. So, why am I saying so? Is look at several celebrities, the recent past. One of our ministers in the Telangana region, he underwent all his tests. All his lipid profile was absolutely within normal. His ECGs were normal. He even underwent a coronary angiogram, completely normal. He was a fitness freak. He was doing his regular workouts routinely, and within just 2 weeks after he got clearance from his cardiologist, neurologist, all the orthopedicians, all the general physicians that he was visiting. You know what? He died. Similar situation with a celebrity, he died too. He was a fitness freak, he was doing well, 42 years of age, died suddenly. Sudden cardiac death. How do you prevent such instances? Is there a possibility to prevent such instances? Number one. Why is the body actually, because see, from normalcy, sudden death is something that is very, very unpredictable, and this is not known. Whatever is not known pretty much cannot be translated into a mathematical algorithm, friends. And that is exactly why we're not able to, though the Western medicine is brilliant in coming up with, cures for acute care and emergency care, and also, it's absolutely brilliant in diagnosing diseases. We are still failing on the prediction, number one, and also on the treatment, on the treatment lines. So what, in this particular celebrity's case, as I mentioned, there were no risk factors, no earlier signs, nothing. It was just all his parameters were absolutely normal. So if you talk about prevention and personalized care, that's exactly where I would like to stop, and then slightly try and give you an outline of the research that we did, and then see and then show the way how we could lead the healthcare revolution from here. So what we did, friends, as I mentioned, see, the foundations of Ayurvedic theory, as I mentioned, see, today you have a problem with determining what levels of glucose are good for you, because of the various standards coming from different organizations. Very powerful and all data driven. Also, your levels of cholesterol. Some people are doing good with your high levels of HDL, and some people are dying with high levels of HDL. So this data again generated by the Danish Research Institute, by the Malinsky et al. Based research institute in the University of California. So as I mentioned, we just started looking at the Ayurvedic aspects of this particular science. What Ayurveda is saying is, if you there's a certain references, when you end up with a balance of three doshas, samadosha, samadinishta, samadhatu, and so on and so forth. I'll not bombard you with the Sanskrit version, but then that's very important because understanding this language itself, is a syntax based. No one understood them properly, and hence no one is able to come up with an appropriate model. So from this shloka, what it means is when these three agents of Vata, the Pitta and the Kapha are in equal proportion in all of the 7 tissues and 42 organs, then the body automatically ends up with physical, mental, emotional, spiritual, and social well-being. That's what Ayurveda says. So understanding the complexity. So first you have the three doshas. Then you have the 5 subdoshas in each of these three categories. You have 15 doshas maneuvering all your metabolic pathways. So you have, if you take a matrix, friends, you have 15 subsets here and 15 subsets in the vertical column on the other in the other tissue. And then if you plot a convolution neural network, you end up with 7 tissues and 42 organs. So you have 7 hidden layers, and in each hidden layer you have another at least 4 to 7 hidden layers, which would correspond to the way these subtypes of doshas interplay within each individual organ. So that's the complexity here, friends. But then the beauty of this is that all this, they're already labeled. You get the data with labels, and the vectors identify, which way the biochemical pathway would move. For example, let's skip. I just mentioned this. So these are the attributes given to Vata, the Pitta, and the Kapha. So I see them as labels in the language of data science, and I'll tell you why they are called as labels. And interestingly, the ancient science not just talks about the Vata, the Pitta, and the Kapha. Friends, it talks about Ashitish Chatva Laksha Rasamritam Swasthya Videva. What it means is there are 8.4 million chemicals present in the body. And these 8.4 million chemicals, the solubility profile is also mentioned. The Jalaja Navalakshani, Stavara Vinshati Lakshani, Gruta Chaturasya Lakshani, and so on and so forth. In the modern sciences, that why we are not able to totally cure a patient is the modern medicine is still evolving. And interestingly, modern medicine says that Harper's biochemistry mentions that there are about 7 million chemicals present in the body. And the ancient medicine talks about 8.4 million chemicals with their solubility profile already mentioned. There are at least hundreds of thousands of verses run to explain the biochemistry involved in this science. So to sum up, it talks about 8.4 million chemicals interacting in Dvam Trinsha Sahasra Kotya Rasayanani Karshan, 32 trillion chemical interactions. And then they are now classified into 21 broad categories of chemical interactions, and 7 of these broad categories guide your molecular pathways, 7 guide the metabolic, and the rest of the 7 guide assimilative pathways, and that's how they were labeled into Vata, Pitta, and Kapha. So this is the theory of Ayurveda, friends. I'm not saying this is absolutely right, but we have some reference at least. And as I mentioned already, so each and at every level of your immunological, biochemical, physiological pathways all are labeled based on their Vata, Pitta, Kapha fingerprint. So, and the target of a doctor is to actually identify the VPK imbalances, VPK for Vata Pitta Kapha, VPK imbalances in each of the 7 tissues and 42 organs with a certain technique called pulse diagnosis, and map those foods. See, this is the trick here. Map the foods that essentially bring about a VPK balance in each of the 7 tissues and 42 organs. Map those Surya Namaskars or whatever fitness regimen that a patient would want to based on his preferences. Your breathing exercises and or pranayama exercises should be also appropriately titrated to bring about a V is to P is to K of 1 is to 1 is to 1 proportions. And your supplements also should be appropriately formulated to bring in those doshic balances. That's pretty much the science structure. So what we did was, because this is all theory, so what we did was we created models of Vata, Pitta, Kapha in experimental animals and created at the end of 1 month, we then measured their action potentials. We just talked about the action potentials in the in the neurophysiology. What we found really interesting was the Vata. So how did we create models? We fed these animals with Vata aggravated, Pitta aggravated, and Kapha aggravated foods. And what we found was the resting membrane potential differed in each of these three under the influence of these three doshas, right? So Vata tissues, look at this, they stabilized at minus 72, Pitta at minus 70 millivolts, and Kapha at minus 108 millivolts. And the threshold was around minus 65 in all of the groups of rats. And the control group of rats, which were fed with balanced diet, their resting membrane potentials ended up at minus 84. Right? So what it means is the Vata systems would need only the difference between the threshold and the resting membrane as the quantum of the external stimulus that is needed for them to elicit an action potential. So they require a lot smaller stimulus. Pitta would require a moderate, and the Kapha signal in a Kapha aggravated diet fed rats would require a larger stimulus. Right? So and because of this difference, it changes the way the sodium ion concentration alters inside the cell and hence triggers different intracellular pathways. So that is really brilliant because there's just one external stimulus. If you give an external stimulus of say 53 millivolts, the Vata systems would produce 7 action potentials, Pitta would produce 2, and Kapha would produce 1. So you see, we really were, flabbergasted at the time when we got these results because it really correlates to what is mentioned. See, I'm trying to explain you how the hyperparameters and how the labels as given in Ayurveda correlate to what is found during these experiments. So, Chalatva is the property attributed to Vata. Chalatva is translated as only mobile, but applying only Paniniya grammar. But unfortunately, fortunately, Sanskritam has 9 sets of grammar principles. Applying a different set, because each matra should be understood in the light of each of these 9 sets of grammar principles. So a matra or a syllable would end up with 9 meanings. If a word has 2 matras or 2 syllables, you end up with 81 meanings. That's why I feel the ancient scientists chose to document everything in this language. Syntax-wise, economy-wise, ergonomics-wise, it's very, very economical to write in that language. So decoding it from there, Chalatva means hyperexcitable. And why is the system hyperexcitable? Why is Vata labeled as an hyperexcitable system? Is because we proved it in the language of electrophysiology. The distance between the resting and the threshold membrane potential is very, very short, and hence they need only lesser stimulus to elicit an action potential. And Kapha requires a larger external stimulus, and then they are labeled as stabler systems, so on and so forth. So friends, this I'll not go deep into this. I'll get into the model very quickly. The idea is that because of these differences in the way they respond to the external stimulus, their metabolic needs are different, and hence their consumption of glucose is consumption of these systems glucose is different, and hence their need for glucose, their need for energy, ATP are different, and hence everything has to be personalized. Your foods, your oligosaccharides, or if you say, for example, rice is eaten in the southern part of India, because most of the people have excessive pitta and vata here. Pitta burns up glucose faster. We found that in our experimental models. Pitta, because pitta, in Ayurvedic parlance, pitta is derived from Agni Tattva, and hence, in animal models, we demonstrated that pitta was actually increasing the mitochondrial activity. So when the mitochondrial activity is high, the system burns up glucose faster, and hence resets your blood glucose to a higher level, so that the pitta systems are continuously fed with glucose whenever they need energy. So that is why pitta systems will not be able to tolerate low levels of glucose, friends. So see, you see, there's a rationality in the way the data is generated, but then the Western medical science is yet to understand why the difference in the way the glucose is consumed, and why the blood tissues in different individuals is resetting the blood glucose levels at different levels. So this is, if this is interesting or understood, then I'll go to the next point. So what I'm trying to say is, what we did was, because of these experiments, several other experiments that we did, we were able to understand what the ancient science was talking about, how they labeled the data, how they labeled the metabolic pathways, and then through certain algorithm, they were talking about personalization. Why? Because, say for example, someone's I was in the beginning of this lecture, I just mentioned that at least 27% of our kidney failed patients in our hospital, you know what, they are millets diet afflicted kidney patients, friends, because we found through the nadi pariksha, and also with the device that we came up with, their pitta levels were aggravated. When pitta is aggravated, the body is burning up glucose faster, and when it's burning up glucose faster, it needs more glucose, and the body resets the glucose at higher levels. If you don't give the body enough glucose or enough carbs that will break down into readily available glucose, then the body starts breaking down fats in a process called gluconeogenesis, and hence, if a certain organ, if the visceral fat from kidney is broken down, such patients end up with kidney failures. There are several instances of liver failure patients. That's why the study of Hunt, two Norwegian scientists, he did a study on statins, retro-analysis of 92,000 patients who were put on statins, which lower your blood cholesterol. You know what he found? Statins lower your bad cholesterol, and hence were supposed to be protecting your heart. And what he found was, at least in the age group between 40 and 60, he found that the statins were actually leading to a formation of a new form of heart failure. Early onset of senile dementia, Alzheimer's, Parkinsonism diseases, and this is pretty understandable. Why I'm saying is this, because based on this BPK fingerprint, you need to customize your yoga regimen. You need to customize your dietary regimen based on the BPK fingerprint already given. The advantage with this science is that the BPK fingerprint is given in this text, in a book called Dravya Guna, of all the foods that you take. The BPK fingerprint of yogasanas is given. Say, for example, Bastrika. You must have heard about the Bastrika. It actually aggravates pitta. So a pitta aggravated individual, Bastrika is contraindicated. So on and so forth, friends. Everything has to be personalized based on this BPK fingerprint. That's what we figured. And then we slowly started doing a lot of modeling in experimental animals, and we found about 3,000 markers for Vata Pitta Kapha quantification. So what the modern science is essentially lacking is this kind of rule-based syntax, which we have understood and slowly started translating into an algorithm. And then we were the only ones. What happens? Okay, when we detected these VPKs, we detected ways and means to quantify them. Very good. What was the end result? When we came up with a methodology to balance the VPK in individual organs, we found that these organs could regenerate. We were the only ones in the whole world to regenerate dead heart. Dead portions of heart after inducing a heart attack in experimental animals. How did we do that? We identified the Vata Pitta Kapha in the heart. For example, as I mentioned, there are 5 types of subdoshas in each of these, under each of these doshas. So Samana Vata, a type of Vata, a Sadhaka Pitta, a type of Pitta, and Avalambaka Kapha, a type of Kapha, were detected and they're quantified, and immediately right after heart attack was induced, these animals were fed with those herbal supplements, dietary requirement per oral formulation. They were not injected; they were just fed. And you know what? Hearts regenerated, brains regenerated, kidney, pancreas, livers regenerated. This led to a really advanced revolutionary concept. So I just try to put into the AI, I put all this logic. I'm not entire logic. I wanted to show you the complexity of how the 15 subdoshas, 7 tissues, 42 organs, 32 trillion interactions could actually interact in the body, and then it produced this image. It's a very complex image, but this is what I'm talking about, the hidden layers of a CNN network that has to be used. Of course, it has to be again optimized further with SVM machines to actually fine tune the margin between the Vata, Pitta, Kapha and their subtypes. And we used all that in our algorithm based on heart rate variability. We not only modeled Vata, Pitta, Kapha but also their subtypes in experimental animals, and correlated that with heart rate variability. And we did spectral studies of that, and we came up with this mathematical model. And what we were able to generate, the data generated from experimental animals was then applied to treat end-stage diseases, friends. We as a cardiac surgeon, I don't encourage anyone to violate any scientific guidelines issued by the scientific congresses. We targeted only end-stage diseases, friends, and then we applied this VPK fingerprinting technique, and then tried to, when we balance, VPK in a real life scenario, we treated patients with IDDM, insulin dependent, got cured. Patients with heart diseases, look at this, this is a block gone. There's a Vata mediated heart disease. There's a Pitta mediated heart disease. This lady, 54-year-old, she was like, her heart failed and her the heart failed, and only 27% of her heart was functioning as opposed to 70%. There's a parameter called as ejection fraction. It went, if it is below 30, you can't even operate. Such people are left with medical management. And after 3 months, she didn't believe that she was able to walk normally. She did an angiogram, then look at this vessel slowly opened up. Here it completely opened up. Not only this, is a kapha mediated individual. Several blocks gone. And these three different heart disease patients had different treatment plans, different dietary prescriptions, different yogasana regimen, pranayama regimen, fitness regimen, and so on and so forth. And so everything customized. There's one of our patients with psoriasis. This guy, had this psoriasis for 20 years. His kidneys calmed off for about 7 years he was on dialysis. 9 months after treatment, his psoriasis gone, which he suffered for more than 20 years. Cancers, brain dead patients. Look at this. This is a brain got completely coagulated after 6 months. The brain develops. This lady who's in coma comes back, and then she started recollecting. That's a very interesting case study. And vitiligo before, during, and after. After 9 to 18 months, friends, that's average lifetime. Crohn's disease, you name it, we cure it. All end-stage diseases. So the model that I'm talking about has helped more than 28,000 patients with end-stage disease. For the past 22 years, 63% of our end-stage patients, friends, who have exactly did what we asked them to do, you know what? The 5-year survival was, in the 5-year survival, they not only just survived, who were otherwise supposed to be dying in the 2 to 9 months before they came to us. They lived for more than 5 years without any drugs, without any Ayurvedic or allopathic. So that is what I wanted to quickly share with you people. And then there's an entire model derivation. This is going to be interesting for people who are into heart rate variability, spectral analysis. I'll quickly, what people are doing right now is because no one understood the complexity of Vata, Pitta, Kapha. They were trying to, train their models with Vata with heart rate or intrabit interval generated from individuals with so-called Vata dominant, Pitta and Kapha dominant people. And, that's exactly where the models got corrupt with this corrupt data, because you don't find pure vata dominance, pitta dominance, or kapha dominance in based on our experimental, and also based on experimental analysis data that we generated and the patients that I saw. 75% are BPK mix, and it's so mixed non-homogeneously that different organs in the same individual have different BPK fingerprint strengths. So that's why you need to identify the VPK 42 fingerprint. That's what I call it. Which means the Vata Pitta Kapha fingerprint in all of the 42 organs. Once you have that, then you need to, based on a certain logic, give this personalized solutions, friends. And we were able to demonstrate impeccable results with this model generated, friends. So if this is your blood glucose level, friends, it could travel three pathways. And in the body, you all engineers must be remembering that chemistry, we were taught something called as Le Chatelier's principle. Every reaction is reversible in the body. If only you knew the path it took to arrive at a certain point. If it is Cossacks plus isonics, then you need to push it back in this way only. If you're able to, if Vata led to this pathway, if Pitta led to this pathway, mitigating Pitta will bring it back to the homeostasis. That's pretty much what I wanted to share because it's going to be too complex. I'll stop here just to take a few quick questions if you have. And yeah, I see that this is the future direction in Gen AI in healthcare, and I'm trying to integrate this data generated. I'm trying to train the model that I arrived at with the data that we generated, and then this model right now I'm using to predict your blood biochemistry, and it predicts to an extent of 70 to 85%, not through photoplethysmography or LED-led spectrophotometric analysis, but through this algorithm of heart rate variability. So that's pretty much what I wanted to talk about with you guys today. Of course, ethical concerns and all, all of you spoke about it, and my speakers earlier have done generous job so that I don't have to go ahead. So our dream is to build this tertiary care model, with polyclinics supporting the, polyclinics being the satellite centers, so that we target end-stage patients and come up with some revolutionary healthcare Gen AI model to automate healthcare delivery and make India the health capital of the world. That's pretty much what I wanted to share. Thank you very much.
So thank you. Really, thank you so much, sir. It is a mind-blowing and amazing session, sir. Actually, gratitude fills the air, sir, as we want to thank you for being a beacon on innovation and leadership, and also by sharing your invaluable insights. Really, your groundbreaking contributions to medicine and commitment to education inspire us all. Thank you for being our esteemed chief guest today, sir. So with this note, we will be taking up the Q&A from the participants, sir. I'm sharing the Q&A to your chat box. The first
right,
Q&A.
it is there. Rajavel, yeah, you go.
Yes, sir.
Are there evidences that Ayurveda has cured schizophrenic patients? Friends, I had at least a dozen of schizophrenic patients that definitely, as long as they were not in the fourth stage of schizophrenia, we were able to reverse, friends. As I mentioned, see, schizophrenia again is from Ayurvedic perspective, it could be either severely aggressive, aggravated kapha in the brain, or extremely low pitta in the brain, or extremely high vata in the brain, blocking of both the pitta and kapha. That's based on the labeling of my data. And then witnessing hallucinations. Yes, friends, I've got several patients. As I said, at least a dozen of them are doing well. Thank you very much for asking these questions. But we are generating data and then slowly publishing them. See, in the medicine, I was not in a rush, friends. I did all that is to be done scientifically, and that's why it took about 32 years for me to get where I am right now. But I have no regrets. We spent our time very well. So the next question is from Logesh. He's asking, so can we train a machine which detects the problem automatically using medical image processing AI, guess the issue so it can reduce the risk of late treatment? See, the thing is here, you can always train a machine learning algorithm with, as I already mentioned, you can always train it. There are several methods that are being essentially deployed today. The CNN is really good. The basic mathematical models, the principal component analysis, the computer vision. Of course, this PCA led to several other machine learning algorithms. They could be used to train the model uh, to detect the problems. That's for sure. The only problem that I, as an allopathic doctor, say I'm fully trained in the Western medicine, and I immensely respect the Western medical professionals. They did a wonderful job. We cannot even, their contribution is amazing. The only thing is, see, as I said, see, we still are figuring out there are about seven, according to the modern science, Harper's Biochemistry, right behind it is in my library. There are 7 million biochemicals present in the body. All right, out of which we know the solubility of only 900,000 chemicals. One more, and Ayurveda, and interestingly, every day we are detecting about 12 to 20 new biochemicals inside the body. Friends, we're still in the process of understanding the body. So that is why treatment, risk of late treatment, yes, definitely yes. But then what is treatment is still not completely understood according to me. And I can definitely go on a debate with learned members across the world. That's what I do. I'm also, research consultant for Johns Hopkins. So while you can predict the disease, we don't know, as I mentioned, what level of blood glucose works in which individual, what LDL and HDL levels should be there in which individual. Because as I see, the BPK, your LDL, HDL, the VLDL, the triglycerides are mathematical functions or physiological functions of Vata Pitta Kapha inside your tissues. Until unless that BPK fingerprint is not known, according to me, you'll not be able to predict which metabolic pathway is aggravated. See, did you know that there are 175 different metabolic pathways that involve glucose, and only 10% of them are dependent on insulin. What do? The moment blood glucose rises, we target. When everything fails, we use insulin. So, the point is, while only 10% of this glucose or dependent metabolic pathways are dependent on insulin, we use insulin everywhere because that's all we know now. Several new pharmaceutical drugs are still in the phase of discovery. So there's a lot to be incorporated and into the modern medicine. And I see we have a perfect fit here. If only I have more help from some of our best data scientists here, we could really come up, take this model, and then show how by integrating our Ayurvedic system of medicine scientifically, not just by rhetoric. No, I see that no one is actually practicing Ayurveda in its original form. That's why I said, okay, we have to take it as a national mission. That's what we've been doing all these years. And then if the end stage care or palliative care and hospice care is supplemented, while acute and emergency care is being taken over by the Western medical science, that will be a perfect fit to the whole world. It's going to be a big boon to the humanity. Thank you very much, Mr. Karthik, for your. I'm a perfusionist. Oh, thank you very much. We work with perfusionists very routinely as a cardiac surgeon. Thank you very much, sir, for your nice words. This AI and medical in the hematology field, yes, absolutely, yes. Abhishek Sabari, yeah. Are there evidences that Ayurveda has good? We already talked about it. Copy of slides? I think so, yes, we can. They're all copyrighted, so you can use that. What specific AI techniques show promise in disease prevention efforts? So that's what I'm saying. First of all, we have to define what is disease, right? So if we're able to define what is disease, then we're able to prevent it. So we have come up with this, BPK 1:1:1 model, and this has to be tested. We're in talks. We're running a clinical. We have already got an IEC approval, and we are trying to run it under the aegis of under the monitoring of the CDSCO and also the Ayush. But getting IEC approvals itself took more than 3 years because no one understood what we were trying to do. Is because we are introducing AI and ML to detect VPK fingerprint, which are supposed to be, according to people's understanding, you cannot detect them, and you cannot have a model, detecting them. So that it took us some time for us to explain so that they understand the logic and science behind it. It takes time. So otherwise, absolutely, I see that if this model is properly understood and propagated, 70% of the diseases can be cured at home, friends. At home, simple diseases. So this A model B, yeah, this is already done. Retinal imaging, yes, but we don't see retinal imaging. We're not talking just about imaging with a dye. We could just take a picture of it. We're taking a picture, all right. We're putting a light on the retina. There's a retina. There's something called as fundoscope. You don't subject the retina to any problem. Really speaking, fundoscope is good enough. All right, so cataracts and astigmatism. There are several reasons for the origin of cataracts and astigmatism. So, Miss Victoria. Thank you very much, Mr. Ganesha. Heart disease and diabetes is always a scary topic. Yes, absolutely. And together, your cholesterol and sugar, this metabolism of glucose and cholesterol constitute or give rise to about 60% of the world's diseases, friends. And everyone talks about lowering your blood glucose, but that's not the way. As I mentioned, you need to check your VPK fingerprint to be able to appropriately treat. Not in all cases does your Nisha Amlaki will help. Not in all cases will metformin help. Metformin will help only in Pitta aggravated diabetes patients. In Vata dominant or Kapha dominant, metformin wouldn't help. These are certain algorithms that I developed based on this model. So there's a lot to contribute to even the modern medicine. The way you prescribe the modern medicines could be personalized with the help of this VPK42 fingerprinting kit. Network sure. Yeah, sure. Okay. Based on data, I'm saying, not to boast ourselves, but then, based on data, whatever we were able to generate, as I said, autoimmune disorders like SLEs, Crohn's disease, ischemic, and I guarantee, when I talk to my patients, I give them that hope. I tell them that I have not invented Ayurveda, I only understood it. But I tell you, the understanding of modern science, understanding of data science, and understanding of Ayurvedic science has really contributed. Each of them have helped me understand the science of life in a much, much better way, friends. So thank you very much. That's for Mr. Deva. Balaji Sitapati. Regarding sugar levels, what kind of treatment is? I just mentioned that you cannot just standardize. Some people, as I said, if the Vata and Pitta aggravated, friends, Vata leads to hyperexcitability of the tissues, and hyperexcitable tissues use up energy faster. When they use up energy faster, they need to be replenished with energy. And the only molecule that provides energy in the body is glucose. Every other glucose molecule, every other sugar molecule in terms of which is like fructose, galactose, lactose, sucrose, aldoses, trioses, tetroses, pentoses, hexoses, all these have to be converted into glucose for the body to be able to convert glucose into energy. That's when you get energy. So people who have Vata aggravation use up more energy and hence need more glucose. So that's why if they need more glucose, they have to have oligosaccharides. So people who have kapha aggravation, for them, your reduction of glucose levels will help. For pitta aggravated individuals, vata aggravated individuals, it might not help. All right, so that's to Mr. Balaji Sitapatiji. Mr. Rajawal, yeah, sure, definitely we could work on, what kind of features can be extracted about cardiac health of a patient through blood and integrate into a model. Yeah, see, Mr. Abhishek Shabari, it's not just about feature extraction that is isolate. I mean, that could be attributed only to cardiac health. So it's not because if there's something called as a spilling over mechanism explained in Ayurveda. In allopathy, it's just that, there are only 36 interleukins that guide all the immunological pathways in the body. And at least 16 of these interleukins get involved in metabolizing your blood glucose. I mean, you're metabolizing your blood glucose levels and also regulating your blood cholesterol levels. Did we know that there are certain non-immune functions to the immune system attributed to the immune system, and some of them are these metabolic disorders. So you see, there is a complex play going on here. So that's why if you talk just about the cardiac health, I don't think we'll be successful. We should talk about health in totality, the health of the body as a whole. So for which, see, the ancient scientists have already classified, labeled the Vata, Pitta, Kapha as the building blocks of the body. For example, if you take this, say, iron metal, I mean a metal piece, put it in an electric environment, field of electricity, it gets electrified. You touch it, you end up with a shock. If you put the same iron piece in a magnetic environment, it gets magnetized. The diatoms align, and you end up with a magnetized iron piece. So it's the same iron piece, but under the influence of electric field or a magnetic field or electromagnetic field or some unknown field, it accordingly gets modulated. Similarly, your body essentially has these three supraquantum fields called the Vata, the Pitta, and the Kapha. If your glucose gets into a field of Vata environment, glucose gets catabolized and you end up with C2H5OH from the same glucose. If the glucose molecule enters a Pitta environment, it breaks down into CO2 and H2 and produces energy. If it breaks down, it gets into a kapha-based environment. The same glucose molecule, builds up into polysaccharide, and then it gets into a storage form. So that's pretty much, the influence of Vata, Pitta, Kapha on all of these molecules. That's why, several scientists have been asking me, so why are molecules behaving differently? They are behaving differently in different environments because the VPK fingerprint of each individual is very unique. So that's why the same chemicals might not act the same way in all individuals. That's pretty much the logic there. So that for which, as I mentioned, see, you need, there are 1.5 billion parameters, right, in the chat 4.0. See, we need 32 trillion parameters. Why? Because the ancient science already has classified them. They have already classified. So what you need to do is understand the 32 trillion interactions in the presence of each of these 32 trillion interactions. That's about 32 trillion to the power of 32 trillion minus 1 times the number of parameters that are already there in the body. And you see how difficult it is going to be. Your large molecules, quantum computing might not be sufficient. I'm just speculating now, from what I understood from Ayurveda. So Ayurveda is a very, very complex subject, friends. People are oversimplifying it, and I tell you, most of these WhatsApp university professors and YouTube people have really damaged health of several of our patients, unfortunately. So I feel this science has to go. And with the help of data science, we'll be able to bring in the complexity of this subject so that, sane people come together to work and then, build a appropriate model. Sorry for this long answer.
Yes, really, really, very thanks, sir. Thankful to you, and thank you for answering all the questions with patience and interest till the end. So I think we have arrived at the end of the session. Dear participants, with an extraordinary journey we have had today in exploring the transformative possibilities at the intersection of healthcare, artificial intelligence, and innovation. Our heartfelt gratitude goes to our distinguished speakers, each luminary in their respective fields, for sharing their insights and vision. Expressing our heartfelt gratitude to Mr. Karthik Ganapathy, Dr. Sanmitra Sarkar, Ms. Anushka Bohar, Dr. Ravishankar Polishetty. Thank you to you all for the wonderful speakers for today's GenAI webinar, for sharing your knowledge, making our session both enlightening and memorable. And finally, I thank Mr. A. Vinod, the founder, and the team of New Biotics for arranging this wonderful webinar. As we conclude this webinar, let's carry forward the collective wisdom and inspiration we have gained today. The future of healthcare is not just promising, it's evolving before our eyes. We thank once again all the participants who have actively participated in the webinar by participation with the insightful questions and their unwavering enthusiasm. As we embark on the path of innovation, let us continue to collaborate, learn, and drive with a positive change. Wishing you all a future filled with health, knowledge, and the boundless possibilities that AI and innovation bring. With gratitude, I am your host, Dr. Nirmala Devi Jagannathan. Thank you once again, and good night to everyone. Participants, thank you so much. Ravi Shankar sir, thank you, sir.